Hi, folks, and welcome to AsyncAPI Conference Day 2. Yesterday, it was obviously day 1. So if you missed it, it was a contributor summit. The recording is available on YouTube and also all the other social platforms that we streamed to. For today, we start a bit different conference because yesterday it was focused on contributors. Today and tomorrow, full focus is on users. So sharing knowledge from users to other users and learning from experience of others. But before we start, I have some organizational announcements, some important information that you have to know about the event. So first things first, surveys. So we have 2 surveys ready to send to you. We're gonna share them from time to time in chat. They include questions. So one survey is question about overall Async API, but there's one pretty important question about the Async API conference next year. How do you see it? So there are just 4 questions. So it's pretty easy to follow. And the other one is about the audit of the Async API brand. So the links will be shared by a group of our good souls, like angels that help to organize the event. They will share with you information about what is the next talk. They will also make sure that the questions are coordinated across all the different platforms. And they will also from time to time remind you about surveys, but they also will remind you about something super important, which is code of conduct. So please remember to respect each other, follow code of conduct, and have lots of good fun. For Twitter people, the hashtag that we would like you to use is AsyncAPIConf. If it comes to the presentations, they were pre-recorded, but it doesn't mean that speakers are not with us. So speakers will join us before the presentation and after the presentation. So you basically see that they are here. They are here to answer your questions during the talk, but also after the talk live. Something I didn't mention yesterday, I think it's pretty important. Huge thank you to Restream.io. So as you noticed, like we were supposed to have the event on Zoom, but we had some technical difficulties handling it all with OBS and other stuff. So we decided to move to Restream because we got for free as an open source project, we got a free license from them. So the whole event and streaming to all the different platforms is handled thanks to Restream. Also, something that we noticed yesterday that we did not know before, we are also streaming event to LinkedIn. So if you're watching on LinkedIn, please remember that like the LinkedIn streaming, it's still in beta. And one of the limitations they have is 4 hours long stream. So basically, like we started stream 1 hour ago. So you have 3 more hours on LinkedIn. Then stream will stop and you're going to have to move to Twitter, Twitch, or YouTube. But all the links are on the conference website. And last but not least, like yesterday, I would like to also thank today, and I'm going to do it tomorrow as well. Just give me a second. I want to share a screen. Okay, so like officially thank to like Async API community that got involved in organization of the conference and the hackathon for this year. Last year when we did online, like we had like around 15 people involved in the organization of the event and just 3 people running the event live. This time the group is much larger. We counted over 60 people that helped in different areas of the conference. yeah, again, even though it's virtual and you're probably alone at home or in office, yeah, please give a virtual round of applause to this amazing community. So thanks a lot. Now we already have Surbhi in the backstage, so let me invite her. So Surbhi, yeah, okay, you're visible. Yeah, the next talk is from Surbhi. It's about time for AsyncAPI specification, and Surbhi works for Walmart. And you have this pleasure to kick off the second day of the conference. And before we start, like, would you like to add something? What people should focus on when they're listening to your talk?
Yeah. Thank you, Lucas, first of all, for setting the stage for me. And I would also like to thank everyone who is actually watching this session. And about me, I'm Surbhi Mittal, and I'm working as senior software developer in Walmart Global Tech. And I am working in the core team in Walmart, which is working on the API governance platform, which is called API Hub. So about the session, so this session will start with the various challenges that our teams in Walmart were facing that were working on event-driven systems, and it will also highlight some of the major reasons why we in Walmart has actually put our foot forward in order to adopt the async API. And then moving ahead, I'll also talk about the async API linter that we are actually trying to create with our own set of rules and regulations. So, yeah, this was all about me and the session. And if there are any questions, feedback, or even suggestions, I will be happy to take them up. So, yeah, Lucas, over to you.
Thank you so much for very well introduced topic. We still have 3 minutes, so I started pretty to basically too fast the stream. We should not start playing the recording, yeah, before the scheduled time. To be fair with people that follow the schedule.
Yeah, sure.
So yeah, uh, if anybody already has some questions 2 minutes before, or especially if it comes to the organization of the event, I'm happy to share more details. I know that at the moment, some good folks are updating our website, so the stream is also like previewed from YouTube there directly on asyncapi.com. And since we have 2 minutes, actually, there's one super important request to the community. I mentioned about it yesterday when we had a talk from Ace about the chatbot. So if any of you watching us, if you know any company that has a past solution and support open source project, please let us know the companies that you know, because we need, as AsyncAPI, we need some funding dedicated to hosting of our services. So things like chatbot, or even some services that we plan to provide as a preview or as demo. We need some platform to host them and pay for the hosting. So if you know some project, some company that supports open source and can offer such services, please let me know. We're in contact with DigitalOcean, but it takes time. So if you know some alternative, please let us know. Okay, so it's 1 until the start. I think it's okay to start. So again, Surbhi, thanks a lot for joining. Especially thanks for joining our Slack, so we stay in touch after the event.
Sure.
That's awesome. And yeah, so let me take us to the backstage.
Hello everyone, I am Surbhi Mittal, working as senior software developer in Walmart Global Tech. I am here to share our experience with async API specification. As we all know that Open API specification is not new, and using it to describe the synchronous REST API is now almost a habit. But how many of us really have standard specifications for asynchronous use cases? Are they even really covered in our governance at all? Our industry comprises of various kinds of frameworks, implementation, solutions. Within this web of wide ecosystem, event-driven systems have established their prominent existence. As a result of which, we have to think more on the lines of documenting the async APIs just in the same manner as we do it for synchronous APIs. Our goal should be to create a standard way of dealing with the event-driven architectures across one's organization. But before moving into how we can write an async API specification, let's first talk about why do we really need one. When the why is clear, the how will become easier. As you can see in the given slide, it shows the initial months of a system when it was in its development phase. This system initially just had 3 producers and 3 consumers consuming the messages being produced in the event bus. Such a system is very straightforward and easy to manage. Eventually, the system started growing and it attracted few more consumers. Still, we really don't find any need to document the async APIs. The system is still pretty much manageable. Fair enough. Now, this is what happened eventually. The system started growing even more, and the number of interactions also started growing. There are more services publishing the messages to the event bus and more consumers who are consuming these messages. Now it becomes impossible to tell what are the possible number and combination of interactions existing in our system. Now, if any producer who is publishing messages to a particular channel, for example, to a particular Kafka topic, wants to know who all are consuming the messages, producer got no answer at all. As a result of which, if any producer wants to make a slight change in the message schema, a change can be as small as changing a key in the message payload, it will end up creating a new topic, as changing the existing topic could potentially cause issues with some other consumers. This can eventually lead to more and more Kafka topics, even though few of them might not be consumed at all. The second drawback is the onboarding time increases because of lack of any documentation. Producers and consumers are maintained by different teams, and it is needed to maintain broker configurations, channel information, and event formats in a central place. Otherwise, maintaining the solution will become a nightmare in the long run. In such a situation, we have what is known as async API specification at our rescue. Now, coming to the reason why we in Walmart adopted async API specifications, a similar thing happened to few of our teams within Walmart. The current slide is depicting one of such use cases where our service change stream was built on event-driven architecture. Change stream was polling multiple databases and it was publishing these changes to the Kafka topics. The problem we faced was we had around 15 services communicating with each other with more than 20 to 30 types of messages with different payloads, and not everyone knew what's inside. So whenever we are debugging something or adding some new key to the payload or making any change to the payload, we would have to contact to the developer who has already worked on it or go and check the code ourselves what's inside it. It was a total mess. Nobody knew anything. We created Confluence pages, we created README files, but all of this used to get outdated every time. So we came into a position where we had no single source of truth for all the services running in our system. And eventually we decided to adopt async API specification to solve these issues for us. Async APIs are consumed extensively within Walmart Global Tech. We have an enterprise level product named API Hub, which is a web-based API design studio, which was primarily but not exclusively built to support the design first REST API development. It provides a way for users to collaboratively and visually design their APIs prior to the implementation. In the slide, as you can see under the API tracker, async APIs are used extensively within multiple teams in Walmart. Hence, looking at such a large scale of async APIs in Walmart Global Tech, we are working on giving support to the async APIs on the API Hub. Now let's call out some of the major problems that async API specification solved for us. Discovering of events and event-driven APIs became easier. If an internal developer wanted to know what this event does or what this channel is subscribed to or what protocol does it use, he or she can refer to the specification to get all this information. And hence, it also increases the reusability of the async APIs. Visibility and discoverability also enhance the productivity of the consumers. Then governance, managing security, access management, and validation of APIs and brokers became much more simpler for us. Let me also give you a small overview of where all you can use the async API specification. With the async API specification, we can describe any event-driven architecture, IoT APIs, streaming APIs like Twitter APIs, Quora APIs, etc. We can practically describe any system that is based on messages. Async API does not enforce any protocol. It is protocol agnostic and it provides a support for quite a good number of protocols in today's date, including AMQP, Kafka, WebSocket, MQTT, JMS, and many more. Now let's move on to the different components in an async API specification. Async API is very similar to OAS. The difference is that it is for event-driven APIs. Using the specification, the developers across the world can speak about what their event-driven system actually does. Now let's get into the mini quick start and see how this specification works. Here is a sample from the specification which we created for our change stream use case in Walmart. I have broken down the specification into 3 basic parts. On the left side, as you can see, sits the reusable building block of your specification, the components. Once you describe your components, you can reuse them in your API or across the APIs. The message tag defines the structure of your event. Next we have is the servers tag. This is where you define your brokers. We have added our Kafka clusters over here. We can also define which protocol are we using. So here, as you can see, we have mentioned Kafka as change stream was using Kafka. Then finally, we have the channels. The channel section of the specification specifies mediums where messages flow through. The channel is something which your app subscribes to or publishes to. We are using the messages tag here, under which we are referencing the component detail correction, which is describing the structure of the event getting published to. Another important thing that I would explicitly call out is that change stream API is a publisher and it's not a consumer. But in our specification, we have mentioned subscribe tag instead of publish. We too had this confusion when we were exploring the async API specification. But the reason behind this is we create an API definition to tell how it will behave for the consumer of that API. In my opinion, it is like ordering our consumers what to do next. If you are creating an API that publishes the messages to the consumer, then you are telling the consumer that they should subscribe to it. So in short, any specification is written for the users of that API, as in for the other party who will going to use the API. Apart from these basic components of an async API, there are some custom extensions that we are using in our specifications throughout Walmart. I would like to talk about some of the major ones. To start with, first is the X-Walmart-channel-prefix, which is kept as mandatory in our specifications. It defines the prefix used in the channel names. We validate this value against each of the channel names defined in the specification. Second is X-Walmart-channel-separator, which defines the character being used as the separator in the channel name. Apart from the value mentioned in this tag, no other character can be used as a separator in the channel names. These two tags are enforcing standardized naming conventions to our channel names. Then comes X-Walmart-channel metadata. If we are using Kafka as the protocol, it's mandatory to mention this tag, which basically defines some of the crucial information about the channel. This information might be important for any consumer. For example, we have defined the partitions in the topic, the replication factor, and the retention days. Another one is X-Walmart-consumers. It defines the entire list of all the consumers. It is not a mandatory tag. And the reason why it has not been kept as mandatory because some of the APIs are consumed externally by hundreds or thousands of consumers, and practically it is very difficult to accommodate such a huge list in a single specification file. But yes, it is a good to have tag. Then comes X-Walmart-business-doc. We recommend to have all the business related details of our API like domain, overview, summary, SLAs, and services. We can also add markdown in each of these, which any tooling system can understand and helps in enhancing the readability. Now, after knowing how can we create an async API specification, we also need a mechanism to validate if the specification created so far is as per the rules defined by our organization or not. For that, we have come up with a huge list of rules which are async API, which our async API specification should follow. To do so, we have leveraged Async API Validator, which is an open source tool. This tool uses AVJ package for validation of messages before the messages get published to event bus. We have created our own async API linter on top of this, which validates if the specification abides by its rules or not. As you can see in this slide, I've listed down some of the many rules that this linter actually provides. Now I'll show you the actual demo using this linter where I'll talk about these rules in details. So as you can see, this is the codebase of the async API linter, which has been built on top of async API validator. The file changestream.yaml is the async API specification that has been created for our publisher application, which is changestream. Now, as a part of the demo, I'm going to run the async API linter on top of the changestream file that we have created. So it will actually tell us whether this file abides by the rules and regulations of the linter or not. So let me run the linter. Okay. So after running the linter on top of this changestream.yaml file, as we can see, it actually gives us a list of some of the errors and some of the warnings. So let me walk you through these errors and warnings one by one. So the first error that it's saying is that x-walmart-channel prefix is must. So as I explained in the slide also, this is a tag which is important to have in our specification file. Now let's say that I give the value of this prefix as CS. So CS here stands for change stream. Now I'll just rerun the linter to see whether the error has gone or not. Now the error is gone, but instead of that, there are two other errors that have come. And the error clearly says the channel has invalid prefix and the channel name is this. So if I go to the channel list, I see here there are two channels or two Kafka topics, I should say, which has a different prefix other than CS. So I'll just go and replace this CDC with CS. Then there is another error which is clearly saying that x-walmart-channel-separator is must. So this is another tag which is mandatory. So I'll just put a / as the value in this tag. The other error is channel name cannot have trailing / and the channel name that is having a trailing / is CDC Retail Correction US. The only reason why a trailing / is should not be there in any of the channel name is that some of the toolings actually replace the trailing / with protocol specific notation. For example, some of the tools replace this / by a dot if we are using AMQP as a protocol. So I'll just go here and I'll remove this trailing / from the channel name. Then there is another error which is x-walmart-topic metadata is must if you are using Kafka as protocol. So as you can see that we are using Kafka as protocol, so we actually need to have this metadata. So I have already stored it here in my file. I'll just simply go and put it over here. So we have put the topic metadata as well. Now this is a list of warnings that we can simply ignore for now. I'll come to this at the end. There is another error which clearly says that contact tag is must under the info tag. No matter how perfectly you have created your specification file, it is very likely that the consumers of your application will get stuck somewhere or the other, and then they will need a point of contact to reach out to. As a result of which we have kept the contact as mandatory in our specification file. I'll give the name under this contact. Then the last error is that says server URL tag containing unwanted keywords, and the server name is also listed here. So if I go to the servers tag in the development stage, if you see, The URL is something dummy URL that we have provided. So there is actually a huge list of words that we have whitelisted, and no stage, or I should say no URL in any of the stage can have those whitelisted keywords. So I'll just replace this dummy URL with the actual URL so that this error also gets rectified. Now let me run the linter again on top of this file. Okay, so now we can see that a lot of errors have gone, but again some new errors have come. Now to start with, the first error says channel has invalid separator. So there are two channels actually, CS Retail Correction US, CS Retail Correction Canada. So these two channels actually have invalid separator. So if you see here, the separator that we used in our tag was a forward slash, but here a hyphen is there. So we need to remove this hyphen and replace it with a forward slash. Then another error is saying that name, URL, and email are must in the contact tag. So in the contact tag, I just mentioned the name, but it's saying that email, I'll just give some dummy email as well as the URL are mandatory. Some URL I'll give again, which is dummy only. Something, yeah. Now again, I'll run the linter and let's see what is the result. So all the errors have been rectified and all we are left with is a list of warnings. So if you see here, this warning clearly states that operation ID and its description are good to have within channel. So operation ID is something, there are various tools available in the market that actually reads this machine readable async specification file and creates the code on the fly. And this operation ID tag is actually used to, give the method names or the class names in your code. So it's actually good to have the operation ID along with a small description with each of the channel. So this was it from the demo site. Now these are some of the references which we explicitly wanted to mention, as these resources really helped us out in our journey of adopting async API specification. Thank you so much.
Okay, so we're back after the recording. Surbhi, you're enabled, so you can start sharing screen, your video. So please, folks, that's the right moment now to ask questions. I'm gonna only make a comment. I was smiling when you reached during your presentation a topic of publish subscribe. It's like a ball that you, like a boomerang. You try to throw it away, but the stuff confusion around publish subscribe semantics always coming back. And it's good that you also pointed out that it's still a confusion. So yeah.
Yeah, actually, it was something that confused us also during the time we were exploring the async API. So I thought of mentioning it explicitly during the session. So yeah, I don't think that there are any questions.
Yeah, let's give people a chance to ask them, because we're streaming to platforms and there's always several seconds delay. So let's wait for a minute.
All right, yeah.
Yeah, and so if there are still no questions, a question from my side, because I noticed like how important for you is the governance of the files, like the linting of the quality of the files. So basically it's the first time I see really people talking about it openly. So first of all, thank you. And did you, I think because we synced before your presentation, did you have a chance to check out Spectral, maybe as a linter tool?
Yes, actually, I got a chance to go through it. You can say it is something similar to what we are trying to develop, but it's just that we wanted to have something in house, like within Walmart.
Okay.
So that's why yeah, this
Okay.
initiative was taken. Yeah.
Okay, cool. Sounds good. But I also like if there's somebody in the audience planning to write some article about Async API and you don't know what topic would be good, I think like linting your files would be a good topic to explore and write about and educate the community. So let me check in the main channel for the conference if there are any questions coming in. Okay, I don't see any. Also, our supporting team. Oh yeah, I think. Wait, there are. I enabled too many questions. Wait, the questions are actually coming. So, first one: what are the missing pieces, tooling, and specification that you felt missing in Async API while working on the standardization of the documentation in Walmart? So, I
Okay.
bet linter is basically one of them.
Yeah, Linder is definitely one of them. And secondly, as I also mentioned before to you, Lucas, that the studio, there is no studio as such, that can help people writing, speed up the writing process of Async API. So I think that is also something we still face this issue, because as we all know that YAML is not very, I would say, not user friendly, but yeah, we make mistakes while writing the YAML and indentation and all. So I think if we have a studio in place to write the async API specification, I think it will be a good
So, the good news
point.
is we have it. So a few days ago, we released a new version of the playground. It's called Studio now. It's much easier to
Okay.
write, and there are like a lots of nice features coming in. I recommend you to have a look on yesterday's conference recording, and there was we mentioned that one of the hackathon winners created a no-code solution to also create async API files. So you basically don't have to write YAML, but have drop down drag and drop components to do it. So
Oh, that's nice.
so yeah,
Okay.
but yeah, let's look on the next question.
Yeah. Is there any of the custom Kafka extensions that you are using that you would like to see as Kafka binding, something like topic metadata? So for now, the only custom extension related to Kafka we are using is topic metadata. Just I as it was there in the session. So maybe we need to figure more on this, but currently we are just using topic metadata only. Then there is.
Yeah, just a follow-up question. But as far as I remember, during your presentation, the topic metadata was on the root of the document, right? Not on a channel or operation, but it was in the root. Right?
Correct,
Yeah.
yes.
Okay. So that's something that we should explore definitely in the bindings. Okay. Next question.
Do you use the async API to generate the subscriber code or resulting schema? Sorry, I'm not able to understand the question. Moving ahead, do you also use the async API to derive some of your unit and integration tests? For now, no, but yes, it is there in our future roadmap, definitely. But currently, no. Do you use a specification for code generation, or it is just like a documentation artifact? So, regarding the code generation, I think there are some open source already there, which allow us to generate the code on the fly using the async API specification. So I think those tools are available on the async API website also, if I'm not wrong, Lucas.
Yeah, yeah, we have some code generators, but like you did not yet explore this area. Like you didn't think about going this direction, like code generation, right? Yet.
Yes, yeah. Then there is for the Kafka payload, can you refer to schema registry?
Like
Um,
technically, it's possible,
yeah,
but not sure if you use it. Like, do you use schema registry for Kafka?
we don't.
Surbhi?
No.
Okay, okay. So, but yeah, technically, the parser that we have supports, yeah, that you can like provide link to external resource. So it can be also a schema registry with your Avro schemas, for example. Any other questions? Okay, I think new question.
Schema registry versus async API. Is there a comparison available? Hmm.
I mean, I haven't seen any official article that tries to explain two topics, but they're self complementary. I think that's how you say it in English. So Async API describes the entire application, and schema is just one tiny part of a message inside Async API file. So it can just play together. You can have your schemas in the schema registry, but then just use references to the schemas inside your Async API document.
Okay.
Okay, any other questions? We still have some time to answer them, so please keep them coming. Oh, actually, we don't, because yeah, we should have 15 minutes break. So let's give 1 minute more to ask questions, and also don't worry if we don't answer them. You can always follow up, putting them in the chat. We're gonna make sure that Surbhi gets access to those questions and can address them. And yeah, good news is that Surbhi joined our Slack, so we're gonna stay connected longer after the conference as well. Okay, but no more questions are coming in. So yeah, Surbhi, thanks a lot for joining, for providing this this presentation. It triggered a lot of questions, which means it was really worth it to come here and share your experience with the community. Thank you a lot.
Yeah. Thank you, Lucas, for giving this stage to me. Thank you.
Thank you.
Thank you, everyone, for joining the session. Bye.
Bye. And yeah, now we up for the break, and in less than 15 minutes, there will be a presentation from Fran about the state of Async API. Take a short break, folks. Hello.
Hola.
Welcome after the break. And my guest is Franciszek Mendezinski. We will start
Rosa Bascura.
Exactly, we will start in 1 minute. Fran will talk about the state of AsyncAPI. And Fran, would you like to introduce somehow your presentation to folks?
Yes. So my presentation is a generic overview of the initiative right now. And there's a lot of information that I had to, on purpose, remove from the presentation because there are lots of things and we don't have enough time. So if anyone is interested in knowing more details, more specific details, we are doing SIG meetings. We're doing lots of like regular SIG meetings. We're open on Slack, so feel free to ask. And if we're not being transparent on something, please let us know, and we'll do our best to make it transparent. Unless it's something private from someone, like obviously we're not gonna share everything.
Okay, so thank you so much for the intro, and let me
Welcome.
start the presentation.
Hello, folks. I hope you're enjoying the AsyncAPI conference this week. I was super looking forward for this conference finally happening at the end of the year, and I hope you were as well. My name is Fran Méndez. I am the director of the AsyncAPI initiative, and today I want to talk about the state of AsyncAPI, the initiative, not just a spec or the tooling, right, but the whole initiative, the people, right, and yeah, just want to clarify something. We do regular meetings for people interested about the specification, the tools, or how to join us. If you're looking for more information after this talk, I really encourage you to join one of our meetings, and I'll be happy to answer any questions, myself or anyone else from the community, and we'll do our best. This one is just a brief summary of the current state. As you can imagine, the time is limited here, and yeah, so really, don't hesitate to join one of our meetings. Let's go ahead. This year started really well, right? Like we've been for like a year, like the last year during the pandemic, we were looking for a way to become sustainable, and we found it. The team behind AsyncAPI, the initial team behind AsyncAPI, joined Postman, and we started growing there with the help of other sponsors like Solas as well, for instance. And yeah, we managed to make it sustainable. But the next step, the step after that, was precisely to make it a little bit less about vendors and more about neutrality. So we had to become neutral. And that's what we did at the beginning of the year. We joined Linux Foundation precisely to demonstrate, to show the community that we want to be neutral. We don't want to be driven by Postman or any other company, right? So it is a neutral initiative. Since then, we've been growing a lot, but a lot. And for those who have been around, you probably noticed that the Slack workspace is much more active. Suddenly there has been like an explosion of people, and that has been fantastic and overwhelming sometimes. Like, oh my god, I can't reply, I can't answer all the questions, I can't engage in every discussion as I used to do, right? So I was personally myself, I was picking my own battles, let's say, and just joining some discussions, and not all of them, right? And so yeah, just to see an example, we passed the 1500 users on Slack, and we're now plus 751 users on Slack this year since December, so we haven't finished the year yet, and that is a huge growth. The chart below, it's not real, it's just for let's say for decoration purposes if you want, but it really looks similar to that one. Like, it is showing signs of exponential, or the beginning of exponential growth. We'll see. Let's see the years to come, right? We also started streaming more often, streaming video content, doing live streams. We could have been recording videos, a lot of videos, but instead we chose to jump into live stream format, because that allows us to speak to the community and to have this feedback loop, if you want, where the community can also participate. We even, I mean, especially Lucas has been doing a lot of these live streams, and we always, depends on the live stream we do, we encourage people to join the live stream as well, even not just the chat, but you can also get an invitation to join live, as even improvising, right? So we want to really make it collaborative, if you want. We increased we increased the number of hours that we've been streaming, and I think this is gonna even get more active in the next year. So really, it's something to take into account. And something that's gonna make Lucas super happy is the number of followers on Twitter. I know that in the beginning of the year he's been doing a lot of work and pushing a lot of content to Twitter, just to make the community there more active, and looks like it's working. So we're growing there as well. So yeah, and yeah, congrats, Lucas, by the way. So something that happened, something that is related to this growth around the number of users coming to Slack workspace, to our community, right, has been also reflected on the technical committee. We didn't have a technical committee per se on the last year, but with the recent joining to Linux Foundation, we had to create one. We wanted to create one, so we created our first technical committee. And there have been a few additions lately to the technical committee, but look at this list. Like, this is only since the beginning of the year. I mean, this is amazing. Like, it's a lot of people, and I was thinking even reading all the names, but yeah, like, they are a lot. I don't want to spend time reading all the names here, right? Lots of names. I have to admit that I don't even know each of them here. Like, I didn't have time to chat with all of them yet, and that is amazing. Like, it is incredible, and that shows what we've been advocating since the very beginning. Like, we want to be open, we want to be community driven. So if you really want to be on the technical committee, you just have to start contributing. If you start contributing, at some point, someone from the technical committee or anyone from the technical committee can actually invite you to, or suggest that you join the technical committee. Usually, if you create a new project and donate it to AsyncAPI, you jump directly to the technical committee. I think that is the shortest path. And heads up as well that we might not accept all the projects. So it's not that, hey, I create a project and I donate it and done. I'm part of the technical committee. So make sure that the community, the initiative wants this project as part of of its organization. But Lucas and the team have been working a lot lately into the paths to become a contributor, and I encourage you to look at this documentation that is available on on our repos. So yeah, I just wanted to show this list because I'm really like overwhelmed in a good sense that we're growing a lot. Like this is huge, and for many more to come in the next years. Welcome, all of you. So that's about people, but what about the money, right? The finances, the money stuff, right? So before we managed to make AsyncAPI sustainable, we were completely based on the donations, like we are right now. But my salary and Lucas' salary was being picked as from these donations. So as you could imagine, like we were getting a lot of money, but we were also spending a lot of money, and we couldn't grow much more because we didn't have that many sponsors yet. But now that we all have a job, like a cool job and a cool company, and that we can just get the salary there, we don't have to touch this money anymore for our salaries. So now what we're doing is we're spending this money on the community as we really wanted to do, right? So this amount of money is just keeps growing, and you'll see it growing even more in the next probably days or months. So yeah, that is. I want to also to say that wouldn't have been possible without the support of our great sponsors. So we have more people sponsoring us, not just this list of companies, but we have also many individuals giving what they can. So that is also super cool. But to list, let's say, the most the sponsors that are giving us the most money is Postman, Solaz, IQ via Slack, Ably or Ably, I don't know, WSO2, Bump, and API Deck or API Deck. So some of you might notice in this slide that I wanted to make a little bit bigger Postman and Solaz logos, something that we have been talking about, but we didn't do yet, and therefore you can join the discussion, is about having different types of sponsors. Let me clarify. So we have different tiers. We have bronze, silver, gold, and platinum sponsors, but this is only about donating money. But sometimes the last thing we need is money. Sometimes what we need is engineering time, or not necessarily only engineering, but time, like people time. So we were thinking, and we were discussing about having another kind of sponsors or partners, if you want. We don't know yet how to call it. That are companies who are not only donating money or giving us money, but also giving us time. And therefore, I wanted to highlight Postman and Solaz because if I recall correctly, I think Solaz is dedicating part-time engineers, like 3 or 4, I'm not sure yet, part-time engineers. So that is cool that they work on AsyncAPI part-time and they donate a lot of stuff, and that is super cool. And Postman team right now is, if I am not mistaken here, I think we are 11 people right now on the team. So yeah, and we keep growing. And 11 people fully dedicated to AsyncAPI and making it grow, and dedicated to the community, not responding to Postman, but making the community grow and responding to our community. So that, thanks Postman for that, because that is super huge, and thanks Solaz for that as well, because that is invaluable. And thanks everyone for the money here, right? That is really, really helpful. With this money, we managed to also create stuff, new stuff, not just ourselves, but the whole not just ourselves, I mean, not just the people working at Postman or Solas or any of these companies, but, with the community. And we recently launched AsyncAPI Studio, which is going to replace Playground and Editor and all the myriad of editors that we had so far. And it is really looking cool. It is so cool that look at the reaction of these guys from Spain, Codely TV, that they just had on their YouTube channel. Have a look.
Habilitando a la izquierda
Vale.
eso y el de la derecha. Mira esto, tío. Puedes hacer zoom, puedes darle al play y se ve el flujo de los eventos.
No.
O sea,
No,
sí.
no.
Sí.
No.
Sí.
No.
Sí.
No.
Sí.
No,
Es
no.
que la hostia, tío. O sea,
No.
dale. Mira,
Qué
o sea,
bonito.
claro, esto es súper sencillo. Dices, a ver, Gañanes, que estamos hablando de una animación de una línea discontinua, pero
Wow, that is amazing. So thanks, Javi and Rafa from Codely. That is an amazing reaction, and that proves that we're working in the right direction. So really, thank you. I was saying that we launched AsyncAPI Studio with really cool features. We launched CLI, but we're also actively working on it, and Glee. Expect a lot of work to happen in the next year on these three tools, especially in these three, plus on the spec, of course. So, speaking about plans, it is not just the tools. We also want to work on the spec. As some of you may already know, we're discussing version 3 of AsyncAPI. It is a tough discussion. It is not tough, but it's a complicated or complex discussion because there's a lot of things to consider for version 3. So it is not just adding one feature here or one feature there. It might become a change of paradigm on how we understand AsyncAPI. And that is super cool and scary at the same time. We have AsyncAPI 3 targeted for April release. We have, if you don't know yet, we have 4 releases a year, and we want to release version 3 on April next year. That said, that is what we want. There's no commitment yet that it will happen on April. We hope and we'll do our best that this is going to happen, but take it with a grain of salt. So yeah. And of course, get involved, because that will make it easier for us to get, for all of us to get there, right? And also, I would love to take the opportunity to say that Specification is one of the less active and participated repos of the spec. We get a lot of people interested in contributing to the tools, which is normal. I mean, people like coding, and we're all programmers, we're all engineers, so we like coding, and people want to code. But the specification needs a lot of love, and there's only a few people working from time to time on that, and we really need more active work on the spec. So if you're interested in helping in shaping the future of AsyncAPI, not just the tools but the spec, because the spec is driving in many cases how the tools will behave, join us. Like, even if you don't have experience, don't feel bad about it. Leave the imposter syndrome out and join us, because we'll learn as we go. We are not specifications experts ourselves either, so let's just learn together. So that is all to say, what are our next plans? Let me just get some water. Some of you might have already watched my talk, The Future of API Specifications, where I talk about an hypothetical future that I would love to see about API specifications, not just AsyncAPI, but API specifications in general. Of course, if that is what I think it will be the best for API specifications, then what can I be advocating at AsyncAPI? I will be advocating exactly this, right? That we go in this direction. So let's have a look at this slide. We have REST, GraphQL, gRPC, messaging, and SOAP. These are like different kind of API or API styles or communication styles, if you want. Like, you know, messaging usually don't fit well into APIs, although I think it's also another kind of APIs, but usually they don't fit well. So or they're not expected to fit into API. So let's just call it like communication styles, right? We have REST, GraphQL, gRPC, messaging, and SOAP. And then we have a bunch of different specs, as you can see there. So let's have a walkthrough. So REST right now can be documented or defined using OpenAPI, using RAML. And if you're using OpenAPI, even though you don't know, you might not know, or if you know, you're using JSON schema. So that's what OpenAPI is using behind the scenes, especially the last version. If you're using GraphQL, you have the GraphQL schema. I was also highlighting there that GraphQL is a specification as well, not just a style. So they call the style and the specification with the same name. So your GraphQL schema is your GraphQL specification. We have gRPC, which has a specification of the same name, and also protobuf. So you can use gRPC and protobuf together, right? We have messaging, which is AsyncAPI, and AsyncAPI allows you to use JSON schema, Avro, and also RAML data types. And finally, we have SOAP. So SOAP has WSDL. I don't know if people call it WSDL or what, but I'll call it WSDL, and XSD. So XSD is XML schema. Can't remember the last letter. Anyway, so yeah, like JSON schema, but for XML, right? So as you can see, the whole thing is complex. It's full of different specs, of different API styles, and most probably, if you're working on a company, on a medium large company, the larger the company, the most probably that you're using many of these styles, if not all of them. So when you want to really use this any of these styles, you will have to choose one spec for REST, or one of them, whatever, OpenAPI, RAML, whatever. Then you might be able to find some tools here and there. OpenAPI doesn't offer any official tools, RAML does, but yeah, OpenAPI seems to be the standard, so that's also another problem. Like you might want to use OpenAPI, but there are no official tools or complete tools if you want. And you might want to also offer GraphQL endpoints, and let's say to simplify that you're using MQTT or Kafka or AMQP, whatever, any kind of messaging. You suddenly have to use a lot of specs and tools, and all of them work differently. And you have to become a master of OpenAPI, of AsyncAPI, of Kafka, or AMQP, or MQTT, or whatever underneath technology. That is a pain, right? So that is a pain because I myself, and I'm sure that many of you can relate, I love API specifications and API stuff and messaging as well, but that is usually not the case among engineers, right? So engineers just are building products, and they have to take care of the security, how they're going to deploy, how are they going to storage information. And one of these big blocks of how to build a product is precisely how you're going to make things connect to each other, how you're going to share data with external parties, how you're going to do microservices, for instance, like APIs, right? How are you going to exchange data? Usually security and deployment and storage more or less have things sorted out. Like storage, for instance, is a good use case that you have ORMs, right? So you don't have to worry about if it's a specific vendor or another. You use your ORM, and that's it. It works. The ORM will take care of translating this query to whatever vendor behind the scenes. Deployment, lately you have Kubernetes and Docker, so more or less is sorted out, right? But when it comes to APIs, that is not the case. We're asking all engineers to become API experts, and therefore what's happening is they will not, and they fail. We're failing, right? We're failing because they're just misusing OpenAPI, misusing GraphQL, and or misusing Kafka, MQTT, whatever other style, or they're just not using any spec at all, which is even worse, right? Because then there are no contracts, there's no guarantee that things are going to work as they're supposed to work, right? So that's why I'm saying that experience here needs to be seamless, and that's one of our goals. One of AsyncAPI goals for the next years, for the next 4 or 5 years, is to provide a seamless experience on any kind of APIs. And that means that we'll have to enter a lot of lands. Like we'll have to be part of the REST community, GraphQL community, gRPC community, messaging, and so on and so on. Don't get me wrong. I'm not saying that we should be creating one spec to rule them all, right? That would be stupid from our side. That is like this meme. I think it's from XCD comics, this comic stuff, that it's there are 14 competing standards, and cool, let's just create a new one to unify them all. The result is there are 15 competing standards, right? So we don't want that. We don't want to create another competing standard. So instead we want to make AsyncAPI become the number one API specification for defining and developing APIs, but any kind of APIs. What does it mean? We don't want to become a replacement for GraphQL. Obviously not. We're not interested at all. We don't want to become a replacement for OpenAPI, but we want people doing REST APIs, GraphQL, gRPC, or whatever other API style to be able to come to an AsyncAPI document, define the interaction by referencing external GraphQL schema files, external OpenAPI files, and the AsyncAPI tools will have to understand these specs. We will not be maintaining these specs. We will be contributing for sure, but we will not be creating an OpenAPI version of AsyncAPI, and we're not gonna be creating GraphQL version of AsyncAPI. No, we just want to integrate the specs. Why? We want to unify this space, and by unify, we don't want to be replacing. We want to be like put in, I don't know if this is something that you can say in English, we say it in Spanish, but it's like we want to put some bridges, right? Like we want to bridge OpenAPI with AsyncAPI, with GraphQL, gRPC, right? And so the users will be able to come up with a single place and tools and process to define any kind of API. I hope that is, I'm making myself understandable. If not, like I said before, I'm always happy and open to any questions. Right after this session, I'll be here, and I'll be happy to answer any questions. But even after the session, I will also be happy to answer any question. So that's it. I hope you enjoyed this summary of the status of the state of AsyncAPI. I always say that I will say like, hey, join us, but it sounds like the typical thing you say, like, hey, yeah, come and join us. No, but I really wanted to say for real, like we're a nice group of people, we're a welcoming community. I say it all the time. It's almost like a mantra already. Every time I speak at a different conference, I'm always hey, we're a welcoming community. So if you're not part of the AsyncAPI community yet, I really encourage you to give it a try. Like, just sometimes, just even the water cooler channel that we have on Slack, where people share random stuff, or just start a Zoom call to have a coffee together in this pandemic, post-pandemic, we don't, not sure yet where we are, times. So yeah, like, join us and have fun. If you're junior, if you're just getting started, don't feel afraid. Like, we're very welcoming with junior people as well, and not just about AsyncAPI. If you need any kind of advice, like you're programming on Node.js or Go and you don't know how to do something, the water cooler channel is also sometimes a good place for asking, and you know, we even have a movies and games and music channel. So yeah, like, I think, I don't know, I might be, it might be just myself that I'm proud of the community we're building here, and I would love you to join us, of course. And also I wanted to finish without I didn't want to finish without telling small story behind how AsyncAPI started. Don't know if I'm not sure if you're aware, we haven't been publicly making noise about it, but tomorrow is the anniversary of AsyncAPI. It was just a coincidence. We didn't plan it like this. So AsyncAPI is, I think, let me check. it is 5 years old right now. It's been 5 years since I pushed the first commit. So just wanted to share that when I first started AsyncAPI, it was really like another side project, like any side project that you might have in your computer. But at that time, I already adopted an habit, if you want, that I was working. Everything I was doing it on open source by default. So I was opening everything by default. I wasn't keeping everything for me at all, right? Unless I was working for a customer or something, of course. So I published this initial version of the spec, and I started speaking about AsyncAPI at conferences and meetups, and soon, I think it was around 2 years, more or less, but it was like super slow. But at some point, it started resonating on people, and people started seeing the value and joining the Slack channel and participating there. I was super active there on the AsyncAPI channel. Sometimes it felt a little bit silly. I was just myself putting comments there and asking questions that nobody was replying because, we were very few people in the channel, and most probably none of them were getting any notifications at all. So, but I continued pushing. Like I wanted to make it open and public. Let's say you're working transparently. And then one day Lucas joined the community, and Jonas and Maciek and other people who were there since almost the very beginning of this explosion, and this started to have a little a different taste. If you're part of the AsyncAPI Slack, you have noticed for sure that Lucas has been given the good mornings every day for probably a year or more, and I think I can't speak about him, but to me it was like a way to show the community that we care. Like we're there. We're not dead. We're still here. We care about you. I hope you have a good morning. I hope you had a good day. Hey, let's have a chat. Let's all form a community, and it's funny because it all started like weird Lucas saying good morning every day. Sometimes you just could see the history of Slack, and it's like Lucas, good morning. Lucas, good morning. Lucas, good morning. Like among many days, and today it's become a habit of the community. So it's not just Lucas anymore alone. Actually, I will say that he's the last person that I expect saying good morning nowadays. We have many other people saying good morning, good afternoon, how you doing? Let's just have a coffee on the water cooler channel, and it all started with a single commit, publishing, like pushing in public. So if you have an idea, if you don't know how to develop further, and you think it's worth it, because it's worth it for you and might be worth it for anyone else, I encourage you to share it. So go ahead and push for your projects. I wanted to say like push for your dreams, but I don't want to sound like we say charlatan in Spanish. Don't know how to say this in English, but I think you get it. Like share it with the community, and don't be afraid. And when I said the community, is the open source community, not just AsyncAPI. So if you have time to contribute to AsyncAPI or any other project, please do it. Contribute to open source. You will not regret. Thank you.
Yeah, I was looking for my napkin.
I was about to cry.
So emotional. I don't even know how to start now.
You see, I knew it. I knew how to make you cry.
Anyone has anything else to add? Some questions except of warm hugs and hearts?
By the way, thanks for all the virtual hacks.
But only Kuda knows how to do them.
Yeah, he's the only one that knows the emoji, apparently. Yeah, in the meantime, I want to highlight this comment from Dave, that he loves the idea that it all started as a side project and a bunch of thoughts. And yeah, that's exactly the point, right? Like of this last part of the talk, right? Like if you have something, share it. I mean, there's something that I didn't say in the talk, but that I was thinking just right now that in this time that we've been working together, Lucas, you and I, we've been fighting hard, not between you and I, but we've been constantly reviewing if we were being open and transparent enough, and what could we do to make it even more transparent and better. And we ended up, we had like we came from talking in private to and then share some things in open, and in along or all the way to let's do it the opposite. Let's not even have a private channel at all. Let's just talk in public, only in public. We have a private channel on Postman Slack for the Postman team, of course. We of course speak in private ourselves between you and I and between people, but we don't have a group channel, private channel, right? That is like a club that you have to be invited or something like that. No, it's totally the opposite, right? Like we were like, so how do we avoid that, right? Like we share stuff in private and we don't share in public. And so we went all in with speaking in public, right? And I think that's precisely what I wanted to transmit here. Like, if there's nothing, instead of saying that, hey, so by default I'm gonna not share stuff or share in private, consider doing it the other way around. Like every time, if you have to think if you can share or not, then consider if you have to share in private, not the other way around. Like by default, sharing in public, right? And yeah, I think that small thing changed a lot of things in the way we communicate and share. I can see everybody's crying in their rooms.
I'm still speechless.
So we have sorry, we have a question, right? So for the future of AsyncAPI, will it be a spin-off spec to point to other specs, or will AsyncAPI evolve? Yeah, so I think it's the first one. Like the idea is not to, I mean, it will evolve for sure, but the idea is not to replace GraphQL or OpenAPI or gRPC, right? The idea is to integrate with those. So yeah, it will evolve in the sense that you might be able, for instance, with OpenAPI, we share the document structure and format, and it's very similar, right? It's YAML or JSON, so that is very similar. So you might be able, we still have to think about how to do it, but you might be able to just embed some OpenAPI or parts of an OpenAPI document inside your AsyncAPI document. So instead of referencing another file, so you might be able to paste it there, copy paste it there if you want. That will be an option probably for protobuf and for gRPC and GraphQL schema. That is a little bit harder because then you will have to include these chunks as strings, and YAML might do the trick, but including this in a JSON file, multi-line strings, that is not easy. So yeah, so that's why I was thinking on this, like referencing external files, so you can keep using your GraphQL tooling along with AsyncAPI tooling, right? In case we're not offering something you need for GraphQL, right? So it's not a replacement for sure. Sorry. So what if you share an idea but it's not picked up? That is like how can I say, like that is life, right? Like you can't make everyone happy, and you can't always convince everyone. If it's not picked up, I'm assuming that it's not picked up because people understood and they think it's not a good idea to include it in the spec. But if the reason is that people didn't understand well, then maybe you have to give it a second try after some time, just to see and explain differently. And if not, there is something that I always said. I didn't mention this many times, but people ask me many times, like, what if suddenly someone develops something like AsyncAPI, like another spec with tools for doing the same thing, let's say, in a different way. I always say, like, go ahead and do it. And if I can, I will be supporting it. Right? Like, I mean, obviously, I prefer that we all work together in the same project and we develop it further. But we can't please all the people, right? So if you have like an idea of how to make it simpler, this is open source. So I will encourage people to actually give it a try. And I don't know, there is the same way there are alternatives to OpenAPI, simpler alternatives to OpenAPI. There could be a simpler alternative to AsyncAPI, like something that is less that has less features, let's say, and looks easier to learn or something. And we for sure will learn stuff together, for sure.
Okay, and the last question, because I think I hear myself. Do you have audio on? Fran?
Yes, sorry. I may. Well, you can.
Okay, thank you. You're so kind. So yeah, I think because we should give people time for break before the next talk. But yeah, let's try quickly to answer this one.
So about this, going beyond APIs, like specification for workflows, gateways, or whatever. Especially workflows, there are many people asking for that, like, but inside the spec, like, like declaring how, like, imagine, like, if I receive a post call to this endpoint, then it will send a message to Kafka or to MQTT or whatever. It's not in the plan, but it can be in the plans. So this is a community-driven project, right? So it is just about proposing that we add that and see what people have to say. And if not, we can always build a specification on top, right, to declare these workflows. Or yeah, I hope that makes sense. But yeah, simple response is make a proposal. That's the best way to know.
Yeah, like because like when you answer a question if it's AsyncAPI plan, it's rather answer your, like, it's not your plan, but
Yeah.
anybody can come in, share use cases, explain how good would it
Yeah.
be. But the most important is use cases and how useful it's gonna be for the project.
Exactly. I came up with a like kind of vision and goals and roadmap for the initiative, but yeah, hopefully not, but at some point I could be given a response from the community that they don't want to implement that, so they want to go in a different direction. So that is my proposal. I took the lead here to define where we have to go, but I am not a dictator. So yeah, we have to discuss everything, of course.
Okay, so thank you so much, Fran, for joining us.
Yeah.
And yeah, everyone, now it's a break, less than 15 minutes and 55 past 1 p.m. UTC. This time difference and time
Brain fuck.
zones, it's really like always killing me. So yeah, 5 minutes until 1 until PMUT. Sorry, look in the comments. There are good people sharing information about new talks.
Much better, yeah.
And yeah, enjoy the break.
Thank you. Bye-bye.
Hey folks, welcome after the break. We will start in 1 minute another presentation titled From Specification to Production, How to Provide a Living Doc of Your Asynchronous Exchanges. And the talk will be delivered this time by two speakers, co-speakers, Ludovic, that you already probably recall from some of the past presentations. That is one of our technical steering committee members. And Antoine. Folks, do you want to add something before we play the recording? Do you want to add something to the audience before they interact with the presentation?
Hi, everyone. Just wanted to thank you for the opportunity to speak. Glad to be here. And let's get to it.
Yeah, I want to apologize. I do some language mistake during the recording, and my daughter joined me during the recording. So sorry for that, but it's live. Enjoy.
No worries. If there will be some confusion, folks, remember Ludovic and Antoine, they're here with us during the entire talk and also after the presentation live, so they can answer any questions you have. But yeah, for now, please enjoy the presentation.
Everyone, thanks for having us today. We are very excited to be here.
Hi, all.
My name is Antoine. I'm currently a digital product leader in a company called Adeo. I lead a team of 12 people. One of them is Ludovic here. And my goal today for this talk is to represent the business side of our work.
Hello, I am Ludovic. I am a solution architect at Ineat Group, and I work with Antoine in the digital products. I am also an AsyncAPI contributor in the Avro schema parser project.
So first of all, a few words about our company for you to understand who we are. So our company was firstly named Leroy Merlin, the logo that you can see in the center. The company was founded just after World War II, and it was specialized in DIY, so in the do-it-yourself industry, and also in home improvements. Business has been thriving since the start. And consequently, the company decided to expand. So now we have some other brands. So you can see the M logo means Bricoman. It's a brand for professionals. We also have a brand called Zodio that is specialized in the kitchenware, and also some other brands. Our expansion was also geographic. As you can see on this map, we are present over 4 continents. We are about 130,000 people working worldwide in the company. Also, our turnover last year was about 25 billion euros, which makes us the #1 player in the European do-it-yourself market, and also number 3 in the worldwide scene after the American players Home Depot and Lowe's. Let's zoom into our team now. Our team is called the costing team, and our purpose is to calculate transfer prices. So a transfer price means an aggregation of everything that happens between the purchasing price at the supplier site until the point of transfer, which can be a border, it can be a point of sale, or it can be in between in a warehouse. Also, our task is to publish these transfer prices to our consumer systems. And obviously, we want this communication to be as effortless, as seamless as possible. So if we have a look on the map, you can see in blue all the places where we sell. And the pins that you can see in orange represent information systems or potential information systems with whom we communicate, because we act as a platform, meaning we act in the middle. So first of all, before us, there is another system that produces article sheets. Then we are second in the ecosystem. We receive this article sheet and we calculate the transfer price. And then the third step is to send back the results, also with its details, to the requester. And in our company, there is really a lot of autonomy, which means in this context that the different business units are not obliged to use the same information systems as their neighbor. Potentially, each business unit may have a separate information system, which makes communication more difficult. So this is one of the reasons why Ludovic brought to our attention the AsyncAPI framework and why we decided to use it, because it makes our life really, really easier. And we will see that in the demo a bit later. So how did it used to work before we used the AsyncAPI? Before we used the AsyncAPI, we had to find where the specs were located, and if we are lucky enough to find them, if we do not have a server error like I often have with my computer, this is why I put these screenshots. So if you are lucky enough to see the specification, we will show you a demo in a minute. Then you will see that it will be a bit difficult to read because it's Excel files. You are not really sure whether they are up to date or not. And more often than not, in addition to the Excel file, you need to call or to write to the person who wrote the specification. So hopefully this person still holds the same position and is able to answer you. And if you are unlucky enough, maybe the person moved to another business unit, maybe even left the company. And in this situation, it's much more complicated to find out what a field means exactly and how to use it. So we can show you now in a demo. So welcome to this company-made tool. It's a very good one, and its purpose is mainly to map information systems and the information flows that help communication between systems. So let's take one random system that Ludovic is selecting just now. So it's actually almost random. It's one legacy system of ours, and here you can see all the flows that are incoming to this application and that are outgoing from this application. Most of these flows are ESB. Some of them are peer-to-peer direct flows. And by the end of the year, the asynchronous Kafka topics will also be published in this solution. So let's take one flow just for the sake of the example. So we can see the URL of the specification. We can open it, at least if it works. On my computer, it doesn't work. On Ludovic's computer, it works. I cannot explain why. So when we open, we can see an Excel document which looks a bit like this. So I guess it's pretty standard over the industries, over the companies. You first have a tab that indicates the versions. And you can see the latest version. Hopefully, the specification is up to date. Hopefully, you never know for sure, but hopefully. Then you have a tab that describes how it works, how to read the documents, because it's not so easy otherwise. And then you have other tabs that describe, technically speaking, how the different fields work. For example, is it a string? Is it a float? And so on and so on. So I think that's enough, Ludo, to show how it works today, or for our team, how it used to work, because now with our new products, we decided to use AsyncAPI, and now our life is much, much easier. And now I will handle the floor to Ludovic.
Thank you, Antoine. So before talking of AsyncAPI, I will introduce our technical architecture. Our costing workflow is in the middle of this picture. and it is based on Kafka system reinforced by arrow schema validation. And so we listen about costing request messages in some Kafka topics. And our workflow provide responses to those requests. We deal with some API call to do calculation, and internally we use the Neo4j technologies to get amount and data in our system. So if we zoom into our main use case explained by Antoine earlier, the idea is to deal with some message producer, which are our business unit partners. And so those partners produce costing requests in this costing request channel. Our technical component or engine process the request. We deal with technical DLQ. If we have some issues, we can send the original request in those topics in order to retry them later. And at the end of the process, we provide some costing responses to our partners. So partners can ask a costing request for multiple business units, so we can produce multiple responses. So how we deal with the AsyncAPI, we have three approaches to document our process. We use some enterprise integration pattern. We also reuse our Avro records to define our message keys and payloads into the documentation. And we do another documentation of the AsyncAPI specification. So about the pattern we use, you can show here that we use mainly 4 patterns: request reply pattern, a return address pattern, a correlation ID pattern. Those 3 patterns work together, and finally a dead letter channel pattern to handle the errors during the processing. The request reply pattern. The idea is to delegate the channel management to our partners to avoid managing too many Kafka topics, because we deal with a lot of partners and it can be very hard to manage each topics. The idea with this pattern is also to send back the results everywhere, depending of what return address is set during the costing request. So AsyncAPI, we use a description field, which supports common mark syntax. So with this request reply pattern, we use the return address pattern. The idea is to ask our producers to set reply topic headers in the costing request with the destination channel in order to produce the responses in this channel. So we use a message header object, is AsyncAPI specification, to achieve this pattern. And we also use a correlation identifier pattern to match all the costing responses we produce related to costing request. So our sender needs to set a request ID headers in the costing request, and we reuse this request ID to define a correlation ID in our responses header. So sorry about that. The last pattern we use is the dead letter channel. So with this pattern, we can handle the non-delivery messages due to some technical or functional issues, like the unavailability of one or API. And to document this, we obviously use the channel object documentation. So in the Kafka ecosystem, we can use another type, which is a specific structure to bring more control over the messages in our topics. And in the Confluent stack, we have a schema registry, and this component bring validation, compatibilities, and versioning for our different schema. And so using those Avro formats is also a way to do a contract first and to generate all our Java models internally for the costing workflow implementation. So the amazing AsyncAPI tooling have an Avro schema parser. So we use it to reuse our Avro file, like you can show in the screenshot at the right side of the slide. To reuse those files, we use a reference object, like the ref attribute in the spec. And this way, our AsyncAPI specification is always up to date, because this specification and our files are under source control in the project source. So the last part is about the over documentation of AsyncAPI. Using some field can be obvious, but it's not systematically used. And in our team, we overuse all those fields to precise and illustrate the role of each element. So I will present to you 4 approaches: the description fields, the example and validator fields, the Kafka binding fields, and finally the tags object. Concerning the description, some fields of AsyncAPI support the rich text representation thanks to the common mark syntax, and this common mark syntax allow you to add links or images or some syntax style into your documentation. And for us, it can provide more precision about how we're using our channel. So you can show in this example that you precise which kind of strategy we use to process the request. And we also add representation of the work of our engine with the image below. And it's also possible to link our Avro file thanks to the link feature to directly provide the real Avro file in our source repository. Concerning the example and validator fields in Avro, so this is a feature available since the 6th version. I published a pull request the last month to support these functionalities. Which you can see at the left side, an Avro structure with some fields. So we can use example attributes to provide some example on each element. And also we support in the Avro schema parser all of the validators supported in the JSON way. So you can precise the min length, max length, some pattern. If you deal with an array, you can precise the min items or max items, and all those validators appears in the generated HTML documentation. We also use the binding functionality because AsyncAPI is generic. We can use bindings to precise some protocol specific attributes. And we use bindings on the channel objects to precise how we manage our topics. For example, how many partitions we use, or how long the message remains in the queue. And for the messages objects, we use the key bindings in the Kafka world because Kafka can handle some key on messages, and this can be achieved thanks to the key bindings, like you can show in the capture here. Finally, we use the tag object to categorize our different events because the costing use case is not the only use case we have in our team. We also deal with season events or business units change events, and so all those exchanges are documented into our AsyncAPI specification, and our reader can easily navigate in our specification thanks to those tags. So I show you how we prepare the AsyncAPI documentation thanks to the specification, and now I will introduce you how we provide a live documentation in production. So I will present to you the AsyncAPI tooling we use, the internal implementation we do to expose the specification, and finally how we deploy this documentation in our infrastructure. Sorry. So concerning the tooling, like you know, we use the Avro schema parser project to support our Avro files and dynamically display them into our documentation. And to generate our HTML documentation, we obviously use the generator with the HTML template project. We don't do some markdown or PDF generation, but it can be done in the future if needed. So to generate this HTML documentation, because we have Spring and Maven stack, we use some Maven plugin. First, we use the front-end Maven plugin to install Node.js and NPM, and also prepare the async generator NPM dependency. And next, we use the exec Maven plugin, like you can show in this screenshot, to execute the AG CLI. So you can show in the command lines arguments that you point on our AsyncAPI YAML file into our project. We use a fixed version of the HTML template to avoid a side effect, for example. And we use two parameters for this HTML template. First, the side organization parameter, which allows us to categorize our events. And finally, the version parameter, which allow you to dynamically use the project version into our generated HTML file. And the output dir is the target dir of our projects. So when we bundle our application, the static assets are available. When these files are generated, we can do a Spring Reactor implementation to expose the static HTML file into a dedicated endpoint. So here it's the async API and the root endpoint, and this way we can provide a live URL of our documentation. Finally, to deploy our costing engine workflow and the related documentation, we obviously use CI/CD platform. In Adeo, we use GitLab CI and in the future GitHub Action. But the idea here is to have a stage in charge of executing the Maven plugin. So you can see here that we can generate from the pipeline the documentation like this profile, this Maven profile. And after that, we have a deploy stage that deploys the Docker image into our Kubernetes engine. And so with all those approach, we are able to show you the complete documentation we generate. So I will show you the final results. Here is our AsyncAPI production documentation. So you can show that there is the version of our project actually. We use an old version of the HTML template, so all the new features are not here, but we plan to upgrade the used version. You can see at the left side that we manage, thanks to the tag, our different event channel. Here we also have the server part with our server URL and the way we need to authenticate to play with. And if I go to the first costing request channel, you can see that the description field bring a lot of detail about how we use the request reply strategy with this image, which bring precision about for our partners. We also add a link to the official Confluent page to explain how the Confluent strategy works and how to set the record name strategy for the producer application. We have some parameters here to keep generic about the name of our channel with different enum values. We also have the operation bindings for Kafka, so we can precise that our producer must set a value subject name strategy property and also set a group ID to access our topics. And if we go to the costing request message description, you can show that the use of the correlation ID object bring indication about how the correlation ID is managed internally. So we reuse the request ID headers. About the headers, we manage some headers. The request ID headers is useful for the request reply pattern. The reply topic headers is required to handle the return address pattern. And we have some other headers, functional headers to do some things internally. And concerning the payload of the request, this is here the content of our Avro structure, which is generated by the Avro schema parser, and you can see here that we have another documentation with the doc attribute used. Some example, we have also here the management of some array. This is not the last version with all the validators and the required fields, but we will update the version of the generator, the HTML template soon. And concerning the responses, we also have a verbose description here. We deal with some parameters, and we can here document the key of our messages, always thanks to our Avro file here. We have also some headers, so we can show here the correlation ID for the correlation ID pattern. We can precise, thanks to the doc attribute, that this is from the request ID in the initial request. And we also have a response payload with possible errors due to issues during the costing workflow. So our partners always also receive costing responses, but if we have internally an error, they are notified with this costing error fields. And if the costing succeeds, we have a costing result object here with the calculation price, the currency associated, some exchange rates, and we also bring detail about about the cost component used during the process. So Antoine.
Thank you very much, Ludo, for all the presentation and all the demonstration. we hope that you understood why we decided to use the AsyncAPI framework and how we use it also. And we wanted to highlight that for us, it's not only a work tool, but it's also a communication tool, and also a very efficient one, as is. For example, when we work with other teams, especially with new consumers, people and teams who want to work with us and to consume our data, this living documentation is our main support of the presentation to show the other teams how to work with us. And also it's a very comprehensive tool because you have in one location, in one package, how to connect with us, exactly what fields, what are the keys, and also an example of a response. And if we compare that with how we used to work in the past, with the Excel documentation that we worked also earlier, it was much more complicated because you had to navigate between tabs to see the structure, to see how it works. And in addition, you do not have an example. If you want to see it in action, you need to go into the ESB to consume one file and then to check side by side the specification on the one hand and on the other the live example. And it's usually by comparing the two of them that you can understand that okay, this field, it actually means that, because with just the label sometimes the term might be confusing. But here with this framework, it's extremely clear, and we have excellent feedback really from the teams with whom we work. And actually the better feedback that we got, I don't think it can get any better than that, was when these teams decided also to implement AsyncAPI in their own products.
So to sum up, AsyncAPI provide a lot of facilities for teams. It's easy to maintain. It's easy to share, like an URI or a Markdown file, or directly thanks to the YAML file. We can provide an always up-to-date documentation thanks to the Avro supports. And today we have not every question about the uses of our different channel because we provide verbose documentation of our exchanges. So what is the next step for us? We think about using the contract first approach to do code generation, maybe with Spring Cloud Stream template. We can bring to us the ability to only focus to our business logic and delegate the technical parts to the generator. So thank you. If you have any question.
Yeah, thank you very much for listening to us. It was quite exciting for us to do this talk. We hope that you now have a better understanding about why we decided to use the AsyncAPI framework and how we use it operationally. And as Ludo just said, we are now ready to take your questions.
Thank you.
Thank you.
Welcome back after the talk. Let me first make sure that the layout that we have here looks good. Yeah, I think now it's looks perfect. So yeah, thank you so much for giving us this talk. I loved, of course, the part when Antoine pointed out that like using AsyncAPI showed others that they also should use it. So thanks a lot for this testimonial. So folks in the comments, please ask your questions now. There was one question during the presentation asking for the slides, so they are already provided in the answer. Before the questions will start coming in, because we have this delay between the studio that we're in and the streaming platform, I'd like to point out clearly that, like, if you noticed when Ludovic was showing the documentation rendered, like how detailed it is and how detailed it has to be for people. And actually, that's just again something, a side comment, folks, like because you mentioned that code generation is next step. Like if you have so much detailed documents already, it's gonna be, I think it's gonna be a pleasure to go with code generation. But my main comment was all these features, like this of correlation ID, bindings, and everything. That was actually a lot of work from Ludovic, like contributing
exactly.
to the project. So thanks a lot for doing
No
it.
problem. It can be possible thanks to Antoine and my company, which is Ineat. They give me a time to do evolution in the tooling, so it's a team working.
Yeah, absolutely. In our team, we like to consider ourselves as pioneers. So when Ludovic has the new ideas like this one, I always tell him, go on, have fun.
Awesome. We all also like to be pioneers in AsyncAPI, so it's a perfect company. Great to hear that. So I think, are there questions coming? Not yet. Let me check other channels. In the meantime, if you want to add some to your presentation, feel free to do it. And in the meantime, I'm going to check the channels.
We are not able to show you the latest version of the generator with all the new feature, because our actual version of our project is not ready for this version, but we plan to do this shortly. So.
Yeah, and also one evolution that we are planning is to make a direct combination between our framework, AsyncAPI framework, and our data dictionary. I know that our data architect is watching us, so we haven't forgotten about you. And the idea is to have a live synchronization between these tools, which would be much more convenient for both.
Perfect. And don't worry that you could not show the latest version. I'm pretty sure we're going to be in touch after the conference. Yesterday, I pointed out that one of our pain points is like clear use cases description, like one place where all the different use cases are described, how people use AsyncAPI. So we're going to contact you to get this, get your use case on page. So, and you're going to be able to share the latest version.
Yeah, nice.
With pleasure.
Perfect. Thank you. I counted you're going to say it. Okay, so there are no questions coming in. So please, folks, remember, if you're going to ask your questions later, we're going to make sure that the questions will reach the presenters for sure, and going to get answers for you. So I would say huge thank you again, Ludovic and Antoine, tuning.
Thank you, Lucas.
Enjoy
Thank you
the
to
rest
everybody.
of the conference.
Thank you, Lucas.
Bye.
Goodbye.
Bye. So, folks, we're going to go now into a break mode as usual, and we will be back. I'm not going to tell you what time. Just look in the comment. There are smarter people than I am that share the information. Where is the next talk? Now the break. Thank you. Hello, folks. After the break, I have two guests with me, but let's make sure that folks, can you hear me? Davy
Hello,
and
folks.
Vim.
After the break, I have two guests with me, but let's make sure that folks, can you hear me? Davy. Hello, folks.
Vim.
After the break, I have two guests with me.
Okay, I think we might have some technical issues. So yeah, let me take folks back to the backstage. But yeah, Davy and Vim are here with us. They will be here throughout the entire presentation, and presentation is about building and managing an extensive API for robotics and IoT. Vim and Davy represent Zora Robotics, and as I said, they will be here during the entire presentation, and they will join us live, and we'll make sure that they will be able to do it to answer your questions. But also you can ask them in chat, and we can make sure to answer also in the YouTube or other channels. So yeah, let me start playing the recording then.
Hey there. Let me start with saying what is ZoraBots. ZoraBots is a robotics company. It's short for Zora Robotics. It was founded in 2011. Hey there. Let me start with saying what is ZoraBots. ZoraBots is a robotics company. It's short for Zora Robotics. It was founded in 2011. And the focus is on making robotics accessible to all. It started really simple with a TV remote controlling the Now robot, the one you see on this slide. And it evolved into a crazy operating system called ZBoss. Now, what is ZBoss? ZBoss is the ZoraBots operating system. We started working on it back in 2017. And well, it was based on all the prior work, of course, but it was a completely new system meant to be universal, cross-platform. And well, you can compare it to like a Windows for robotics, basically. So there's an Android, Java virtual machine, and a web version via Kotlin multi-platform. These are most of our robots that we support. You have Cruiser here, Pepper, James, the small one is Robin, then now that you saw the first slide. Billy, which is an interactive flower pot. Aimbot helps with the pandemic. And Sawyer is a big robotic arm. We also support virtually any Android device. And we have a version running on the web with virtual robots. You see the virtual Zora there in a virtual home. You'll have a control application which works on your phone or on the web. It allows you to control your robot, the virtual robot, or an actual robot. This is the website if you want to check it out. And everything runs on a single API. That's what we're here for today. So our API is based on MQTT. There's a broker on the robot and a broker on the cloud. It's rather huge considering it's 600 channels across 26 categories. And I hear a lot of people in the AsyncAPI development are using it for benchmarking things because it's so huge. So that's quite funny. You can see our documentation on the link below.
So essentially, we have two brokers running, MQTT brokers, one on the robots, which you can see on the left here, and one in the cloud. These two brokers sync each other, and we mainly made one in the cloud so we could remotely access the robots through our control app. Since we access and control the robots through an MQTT API, that also means that third parties can integrate to it. you can either run an app on the robot itself and connect to MQTT, or you could even have an external app running somewhere, for example, on an IoT device, something maybe that monitors the air quality and then reports it to the robot or stuff like that. These are some examples or API of our topics. For example, what we do a lot is we have a publish topic to request something. In this case, we do a battery gets because we want to get the current battery state. And then below it, you see the response. We always work with passing a key in the payload, and then the response contains that key, so you know that the response is for you. Since it's a broadcast system, you have to do something like that. And the payload is mostly are JSONs. For example, in this case, you get your battery level and percentage. You know if it's charging or not, and you know if it's docked or not. Because we don't want to poll to for the battery state, you can also listen to the battery event topic, which does the same as the response, but publishes it's once in a while, every time it changes. So that's just one example. We have a lot of topics. You can control movements, you can play audio or set of volume levels, you can open a camera stream, take a picture, turn on the lights, change the color of the lights if the robot supports it. You can play media, play audio, or show videos on or images on the screen if the robot has a screen. You can let robots say something through text-to-speech, which we support for multiple languages. You can listen to sensors. Some robots have like bumpers or buttons which can listen to, and also motion detection and face recognition through the built-in cameras, or listen to a voice command. If a person says something to the robots, you can then do something. So we also support automations. We have through our control, we have a composer system where you can essentially place blocks. Think Scratch or Node-RED, but specifically made for ZBoss. And we also have a scheduler, so you can start automations on specific time points. We also integrate domotics through Home Assistant. So Home Assistant publishes data to our robot, and you can act on it. We also support third-party apps. They can integrate into ZBoss by, for example, adding themselves as an app. They can register themselves as an app, so the user can see the app visible on when he fetches all the apps and control. You can add settings which the users can then change, custom translations. You can add monitoring if you have a monitoring device, for example, a CO2 meter or something like that. Then, as we have an extensive API, we surely had to document it. In the early days, we just updated a page on Confluence where we had a list of all topics and a description of them, what payload had to be sent in it. Of course, it was hard to maintain. It had to be updated every time we changed something in code. It was always out of sync, and it contradicted the actual code. Also, it wasn't easy for third parties to read out the API. So we started using AsyncAPI. So at first we just made manually we made a YAML file where we put in all the topics and payloads and stuff. It was quite easy to maintain, but all developers had to learn the AsyncAPI syntax because they had to update the documentation every time they changed something in the code. And it happened that something was forgotten and it was still out of sync. So what we essentially did was we made multiple YAML files per category, and then we used the YAML Inc. Tool to sync those files or merge those files into one big one, which we then published. So we wanted to make that progress better. We wanted to automatically generate the documentation. So we went one step further and we let the AsyncAPI file generate from code. So it was at that point it was easy to maintain because we didn't have to manually update it. The code and documentation was always in sync, and we because we generated the code file from code, we didn't need to make any code changes. We didn't need to change our data classes or something like that. Downside is we need a lot of annotations in our code because we had to say, okay, this topic has this description, so we had to annotate that, and we had to add some custom code to make this all work. And it doesn't always form the nicest docs. Sometimes you can make a more proper doc when you manually make it, but we found it wasn't that big of an issue. So why did we decide to essentially work on a code-driven way? So in a perfect world, we could have just made an AsyncAPI and then let our Kotlin code generate from that. For example, we could have defined a battery event in an AsyncAPI, and we could then export it to a Kotlin class, and it would look something like this. For example, we would have our battery event with a level, if it's charging or not, if it's docked or not. Of course, that's not how the real world works, I'm afraid, because our data classes aren't that easy. We had, for example, to add some annotations. We had to add serializable annotation for our JSON parser. We had to add the JS export annotation because we wanted to make the data class available from JavaScript for our Kotlin multi-platform integration. Some other problems, again, we had some annotations like the serial name. JSON parser, which says Kotlin multi-platform, doesn't automatically convert camel case to snake case. So we had to add serial names. Sometimes we had our functions in the data class itself. For example, this one, if the request is valid or not. Or for example, these ones where we made some helper functions. If you get a jar and it's null, then instead return 0. So we could work around it, but that would mean we had to do a lot of code changes. Some classes I don't think we would be able to work around. For example, we have an enum here, which we give a parameter to. We have a custom serializer, which is also added to an annotation. And because some bug in Kotlin, we also had to add a companion object to make that serializer work. So this would be hard to generate from a AsyncAPI spec file. So that's why we chose to generate the AsyncAPI file from the code. So how do we do it? We essentially have a Kotlin MQTT library where all our MQTT topics and data classes are defined. And we made a generator, a AsyncAPI generator app or library, if you will, that integrates that and then generates an AsyncAPI JSON file from it. For that, we made use of the JAsyncAPI library, link you can find there. How does that work? Well, essentially you can define an AsyncAPI and encode instead how you would normally do in a YAML or JSON file. So, for example, below in the code, we would create a ZBoss MQTT API class, and then we would serialize it to JSON and then return to a file. So how does an MQTT API or an AsyncAPI class look like? So here on the right, you can see we have a class that extends the AsyncAPI class, which comes from the library. And there we have to override some implement some functions. For example, the getInfo function requires you to return an info object, which you can find on the left side of the screen, which you just fill in with some metadata you normally find in an AsyncAPI file. For example, the title, the description of the API, contact information, the version, stuff like that. The same is essentially done for other things like servers or all available tags. However, it's the components part that we wanted to, the channels part that we wanted to automate. What we did is we made separate classes where we grouped some of our MQTT topics. For example, we have here the battery channels class, and there we return, I'll go to the code the next few slides, but we generate some publish and subscribe topics, and we pass our MQTT topics, which we already had in the library. So we create a publish here for battery gets, a subscribe for battery response, and a subscribe for battery events. So what is that constant? For example, we have the event. So the battery event I mentioned on the previous slide is here. It's just a static string. The static string is used in multiple of our projects where we pull in that Kotlin library, and we then consume those constants to do our subscribes and publishes. But we had to add extra information, of course, to make sure we could generate AsyncAPI docs from it. So we opted to add annotations to each constant. So for example, we would have the add topic summary annotation, which would then add the summary, and the AsyncAPI docs, the description, and then the data where you would pass a class in. The class is the payload you would send typically for that topic. So in the class itself, we also added some annotations. For example, if you wanted to add a description to a property, you could add it by using add property description. Or we also made some small helper annotations. For example, the property schema, which you could then add, okay, this is percentage, the level of a battery is percentage, and it would then automatically generate the minimum is 0, the maximum is 100, add a description to it, stuff like that. So you didn't have to add it every time you had a percentage property in a class. So how do we process those annotations? We use reflection for that. So we in Kotlin you can get the properties of a class or of a field, and then you can get annotation from it, and then get the data in that annotation. These are 3 examples: the summary, description, and the data class. Now, these methods that I just mentioned, you can then call. We would, by using the AsyncAPI library, we would build an operation and then add the summary, description, and message to it, and we just get the information from the annotation from it. The message, so the payload required some extra code because that's more complex. And it's a simplified version looks something like this. So you would build a schema, and in that schema you wanted to set the properties. The properties are then retrieved from the primary constructor of a Kotlin class, which is essentially the constructor, the only constructor a data class normally has in Kotlin. Then we would loop overall parameters in it in the constructor. We will check what type it is. We would check if it has annotations and get those and fill the information in as well. If we see that the type of that property is not a string or an integer or something like that, we would, but it's an object, we would then recurse and get the properties from that one. So we would have a nice tree in the schema. Of course, more had to be done. For example, the serial names we used for our serialization, we had to use that one, those ones, instead of the camel-cased names we used in the code itself. We also had some non-constructor fields in some places we had to add. We had to add some special handling for arrays and enums and objects. We also had to prevent infinite nesting. Sometimes a property in a class has the same class as the class itself, so it would just keep looping and have an infinite nested code. So of course that's we had to break up. And there are some other cases as well. The only thing we still added manually is examples. We weren't able to add those through annotations, but we just added them, and after we generated the AsyncAPI schema, we just added an example for example, battery event, then level, and all the properties filled in. So it would show up nicely as an example in the AsyncAPI documentation. The outputs from that library is then one big JSON file, essentially containing all topics, but we also opted to create a JSON file for each category separately. The reason we did that is because we wanted in our web portal, in the documentation portal, we wanted to split up everything into separate categories and then load one of those JSON files depending on the selected category. Showing one big page wasn't user-friendly and not performant either, so we opted to do that. The big JSON file mainly exists for third parties who just want to integrate everything while they can use that file. So it's also integrated into our CI/CD. Every master build we do, we run the code to generate the documentation, and it's then published to our public Git repo. So that means it's available immediately every time we do a release. And it's also tagged with the version that we released at that point. It's also integrated into our documentation portal. And Wim will give more information about that.
Thanks, Davy. So what we see here on this page is our documentation portal. On the left-hand side, you see all the categories in our API. On the right-hand side, you see all the topics you can subscribe or publish on. And of course, the details in the center. You can find this site on docs.zorabots.be. Everything is built with Antora. Antora is open source documentation tool. And all documentation in it is written in AsciiDoc. AsciiDoc is like Markdown or other markup languages, except that it's quite advanced to make structured documents, so it's perfect for manuals and technical writing. What it does basically is aggregate documentation from multiple sources. As our documentation, our AsyncAPI API is just published to a Git repo as well. We use the tools created by David Jenks to convert it to AsciiDoc and then integrate it into our doc portal. It's really nice because it also generates the navigation and all the cross links between different topics. So it's a really nice tool. We also consume our own async API in the ZBoss control application. So there's an MQTT block, like a building block in our programming environment, where you can publish and subscribe to topics. You can connect to multiple MQTT brokers if you like. So this is how it looks basically. All the topics that are in our API can be searched easily. So as you can see in this list, if you click the information icon, you get some more information about this topic. All those things are rendered from the Async API spec. And then if you select to use one of these things, it ends up in the block and you can change the payload if you like. In this case, you are checking the battery status of a robot. As for future plans, we've been working a lot on a virtual environment and virtual robots the past year. And I would say that 95% of what we've been doing is not even live yet. So 2022 looks really nice when it comes to releases. We want to further expand on our Composer application because there's a lot of opportunities in education, especially because everybody knows robots are expensive. And if you can have a virtual robot that does all the same, it's perfect for STEM classes and stuff like that. So our focus will continue on virtual robotics as well, as it's just all the same codes as for the real robots. And part of that is building a community of people where they can share their own compositions, as we call them. So they can share their own programs they make with our software and improve upon it. And another step there is to allow third-party integrators to easily interact with our system, make their own composer blocks, which are like the fundamental building blocks of our system. So these are the things that in 2022 we are really looking forward to. If you are interested in more of that, I set up a mailing list. You can subscribe to it. We can give you a free trial to our virtual robot platform the moment we launch it. So please do. Don't worry, we won't spam you with anything else. This is basically, I made this list just for this presentation. If you like what you heard and you want to participate in our projects, please feel free to reach out on jobs@zorabots.be. Thank you very much for your attention. If there's any more questions, me and Davy will be there just after this. Thanks.
Hi, folks. After the presentation, first of all, my apologies by how we started the presentation. Of course, it was a technical issue on my side. I could not see folks, and I thought you can't see them too. But of course, sorry for that. But thank you a lot, Davy and Vim, for joining us and taking time to record it. I mean, would you like to add something to the audience before we start getting questions, because we have delay, so we're gonna wait a few seconds for the questions. So
first of all, maybe Łukasz, we would like to thank you for the invitation, and also you and a lot of other people in the AsyncAPI community who were helping us while we were learning to use it. So thank you very much. It's a really nice community.
Thank you. Thank you for nice words. And question for me, because for me, the last slide about the plans for next year, like no code and also to third-party integrations, I guess it's all somehow gonna be related to AsyncAPI, right? Because it's you need it basically to enable that, right?
Well, yes, everything that we do works with MQTT, but of course you don't need to use our API to use our software. We have a graphical programming tool where you just drag blocks. But of course, for more advanced users, you could link with MQTT with it and use our API with it. So it depends on the level of the user, I would say.
True. Cool. More and more no-code solutions. That's maybe that's not the event about it, but I think it's also a future where everything goes. So, folks, remember, you can ask questions now. Feel free until we have folks live. Okay, we have a question from Fran. Let's have a look. So you showed us a kind of downside that you have to use a lot of annotations. How do you think we can get rid of those?
It's a good question. I think we need those at the moment, since we do a code first approach. We need some way to say, okay, this topic has this description or other data. So it's a downside in the sense that every time we add a new topic or something, we have to add a bunch of annotations to it, which is more work and not so pretty in the file, but I think it's a necessary evil, and it's worth it to do it that way. Can't find any alternative way at the moment.
Thank you. Any other questions? Our angels that help out coordinate the questions, please paste them. In the meantime, I'm not sure if you're aware, but yesterday we announced winners of the AsyncAPI hackathon, and Sovik created a AsyncAPI bundler, and he won a hackathon. His whole idea was based on your use case, where you have one file, but you also have multiple split files, and you need to bundle them into one. So your use case inspired a hackathon winner.
That's very cool to hear.
Yeah. Okay, I don't see any more questions coming in. As Sergio confirmed. So thank you so much so far. If somebody didn't manage to ask a question, as usual, we're gonna make sure that your question reaches Davy and Vim. Thank you so much for taking time to record the session, to come also to the conference, to be here with us, and see you later on Slack in the community.
All right.
Okay. Bye-bye.
The slides are online if you need them. So
yeah,
I have to mention that.
Yeah. And we after conference, we will also release every presentation separately, not just as a stream. And always slides will be in the description. So for those watching, if you were thinking about it, yeah. And also important now, there was a information from Sergio posted in the comment. So if you would like to share feedback about this presentation and other presentations, we always put links to the schedule where you can provide information. So yeah, but yeah, again, thank you so much. And yeah, let us now start a long break, 1 hour break for having something to eat, for Americas to wake up, and continue with the presentations. Thank you.
Bye.
Bye.
Hi, folks, and welcome after the break. Well-deserved break. I hope you enjoyed it, and I hope Americas are awake already. Before we will jump into the next presentation, the time zone is pretty different, so we owe you some organizational announcements like information for next 4 talks. So first, the most important, please look into the chat. There's a group of awesome people helping out organizing the event. They share very important links. They share surveys that we would like you to answer to. There are 2 surveys, one about the AsyncAPI brand and one some overall questions, like 4 questions about AsyncAPI and most important about the AsyncAPI conference next year. So please pay attention to those links and take time to answer to them. They don't take much time. Also, as a reminder, please remember that we're all here to really learn and have fun. So remember to respect each other, respect the code of conduct for the event. The Twitter users, remember we have a AsyncAPI Conf hashtag, so please use it to spread the news about the event. If it comes to the presentations, they were pre-recorded, so we will play recordings. But it doesn't mean you're left alone without speaker. So even though the talks were pre-recorded, speakers are still with us here. So speakers will always join for a minute before the presentation to show up that they're here. And also there will be, thank you, Fran, for showing the logos. And of course, speakers will also join live after the presentation to answer your questions. What else? Something to point out. I'd like to first of all thank our platinum sponsors, but also the gold and silver sponsors of the event, and a special media partner, let's call it this way. So Restream.io, that offered us a special subscription, so we can actually host this event here on Restream and stream to all our different AsyncAPI social accounts. So thank you so much. LinkedIn. So one of the platforms where we stream is LinkedIn, but LinkedIn is having a beta still if it comes to streaming, and it's limited to 4 hours. So the stream for LinkedIn is over. So sorry about that, but you already probably realized if you were using LinkedIn. So I hope you managed to get into the different streaming platforms. Super important. Last talk from today that was supposed to be done by Jai Deba from PayPal. Unfortunately, it has to be cancelled. But the good news is we're in contact with Jai Deba and we will for sure share how they're using AsyncAPI at PayPal. We will just do it differently, not on a conference, but as a blog post and a use case description. Instead of this presentation, so we're not shortening conference today, we will just have a different presentation. So yesterday when we announced in one of the channels that, we will have to skip one presentation, or suddenly community responded. We, instead of this presentation from PayPal, we're gonna have presentation from Fran Méndez about designing event-driven architectures with AsyncAPI, and there will be super nifty demo of one of the AsyncAPI tools called Glee. Please remember about this. And last but not least, as you know, when we started organizing this event, we started with registrations on Zoom. And the idea was that the presentation will be held on Zoom and then streamed to also all the different streaming platforms. Due to technical difficulties, we had to drop Zoom. But as an apology to the community that of all the hassle and the communication about the different streaming platforms, We took down the list of all the email addresses of all the people that registered. And next week, Wednesday, during the contributor first stream, we're going to do a draw, a raffle. Basically, we will select randomly people from the list and send them a AsyncAPI swag pack. Yeah, I think that's all the most important information. So for now, I'm taking a longer break, and I will invite Fran, who will take over. Excuse me. I'm not sick, so it's not because I'm sick he's taking over. So, but yeah, Fran, hello.
Hello again.
So yeah, take like in next 3 minutes, please entertain people somehow, and then let Dimitrios in for the next talk. And it was a pleasure. I'm gonna be somewhere in the backstage. Good luck.
All right, so I'm gonna take over now for the rest of the conference, I guess, unless Lucas wants to come back and join me. I think we're late to the next talk, maybe. Am I right? Let me just check the schedule. Yeah, we're late for 7 minutes. Am I right? Yeah, so let's just not well, let me invite Dimitrios to the stage. All right. Hey
Hello.
Dimitrios. So thanks for joining us and doing this talk today. Dimitrios, how should I pronounce your last name? Like Dedoussis?
No, that's the French pronunciation. It's Dedoussis.
Dedoussis.
It's a Greek surname. So yeah.
Okay.
But yeah.
Okay. I was curious. Like, is it French or? So where are you joining from, by the way?
So I'm joining from London. So yeah, I'm originally from Greece, but I've been in London over the past like 10 years, studying there and then working. So yeah, very glad to be here and very excited to share my presentation recording.
Awesome. You've been doing a great job on the socket.io. So you even created a series of blog posts. So yeah, it's not a new topic for me, and I guess it will be new for many people. So cool. Let's just go straight to your presentation. Let me try to find it. I hope I can find. Okay, here I have it. Cool. So let me just. So how to document a socket.io API.
Yep.
Cheers. See ya.
See you in a bit.
Hello, I am Dimitrios, and I'm going to talk about how to document a Socket.io API. This is a talk that is going to be primarily focused on Socket.io, but I hope it can provide a good example on how to document any event-driven protocol using the AsyncAPI specification. So this is going to be one of the long sessions of this conference, so I think it would be wise to briefly outline some agenda first. I'm going to start with quickly introducing myself and then telling a story from real life on how I discovered AsyncAPI and how I got motivated to combine it with Socket.io. Then I'm going to talk about what Socket.io actually is and how we can model this protocol using the AsyncAPI specification. Towards the latter stages of the talk, we're going to get a bit more practical and try to put together an AsyncAPI file from scratch, given an existing Socket.io API. Finally, we're going to talk about Asynction, a framework combining both Socket.io and AsyncAPI, and hopefully we're going to get some time for Q&A towards the end of the session. I'm now going to share a link to the slides in the chat so that you can navigate through the content at your own convenience. So a few words about me. I live in London, and as you can see here, I chose a photo of London that is pretty characteristic of the London weather. I work at Babylon. Babylon is one of the world leaders in digital healthcare. Our mission is to deliver an affordable and accessible healthcare service to the hands of every human on earth. I am a senior software engineer in the AI chatbot team of Babylon, and throughout my career I've been building distributed systems and cloud-native workloads, mainly in Python and in Node.js. I do have a passion for open source and big data applications. If you're interested in what I'm working on my free time, you can check my GitHub profile and my Twitter account using the Dedoussis handler. I've also recently started blogging in my personal website, and this blog includes articles about this exact topic of AsyncAPI and Socket.io, so if you're interested about them, you can certainly check these out. I'm also the author and the maintainer of Asynction, which is a Socket.io Python framework driven by the AsyncAPI specification. We're going to talk about Asynction in detail towards the end of the talk, so for now you can just stargaze it on GitHub. So how it all started. So my adventures with AsyncAPI date back to the early 2021, where in the chatbot team of Babylon we wanted to extend our chat platform with human-in-the-loop capabilities. So long meetings would soon follow about the design, so whether we should pick a framework X or framework Y, or whether we should go serverless or not. Eventually, the stack of the team, which is Python, Flask, and Kubernetes, pointed us in the direction of Flask Socket.io, making Socket.io the protocol of choice. So this felt a rather unorthodox design process. One could describe it as a stack-driven design process. So the stack and the expertise of the backend team dictated the choice of protocol. I think it would be better if the business requirements or also the requirements of the front-end team contributed equally towards the protocol decision. Thankfully, Socket.io is a very carefully designed and very well maintained protocol, and it ended up fitting our business requirements and front-end requirements and not just our backend team requirements. So essentially we got away with it. So as we moved onwards towards the development phase of this project, I started looking into how we can document our application before actually developing it. So the purpose of this thought was that we could share a contract with the front-end team, and they can start developing their stuff independently to us. So I started looking online on how one could document a Socket.io API, and to my disappointment, I couldn't find any resource on the topic. I tried to zoom out a bit and started searching about how one could document a WebSocket API. Still didn't find many resources. I found a few, but no standardized or widely adopted solution. So it was at this point when I realized that documenting event-driven APIs is treated as a niche area of the industry, which is kind of absurd, because the actual event-driven architectures themselves are pretty popular, especially throughout the last decade. So this left me rather disappointed, especially because I come from a REST and GraphQL world. So for example, in the REST API world, we have the Open API initiative as the de facto standard, and also in the GraphQL or gRPC protocols, everything is strictly typed and contract driven. So it feels that these kind of APIs have managed to solve this problem for quite some time now, and that the event-driven APIs have lagged a bit behind. So moving onward with my long Google search, I finally came across AsyncAPI, and I was delighted to realize that there is a community out there that tries to solve this exact problem of documenting event-driven APIs. And I was even more delighted to realize that this is a very active and passionate community. So I skimmed through the AsyncAPI specification, and I figured out that this is a tool that I could use for my own problem to document a Socket.io API. So I started looking into how one can document a Socket.io API using the AsyncAPI specification. The only single resource I managed to find online was this Stack Overflow question, which is a very old one and also an archived one. So in the title it says recommendation on how to document WebSocket APIs, but the actual content of the question is about Socket.io APIs. So this question had only a single answer, suggesting the use of AsyncAPI version 1 and also suggesting it to use in a not very correct manner. So at that point, I realized that no one has really attempted to document a Socket.io API with AsyncAPI. So I decided to take on this challenge and, if successful, write a blog post about it or give a talk about it. So here we are. So before trying to model Socket.io using the AsyncAPI specification, I would first like to establish some basic and common understanding of what Socket.io is. Many would argue that Socket.io is a JavaScript library for real-time web applications, and I wouldn't blame them because this is what the Wikipedia article actually states. However, I do regard this as an outdated definition. I see Socket.io as a protocol of its own, with a JavaScript library just being the reference implementation. It is a protocol enabling event-driven communication. It is a protocol enabling low latency duplex communication. And it is a protocol supported by the underlying mechanisms of WebSockets and HTTP long polling. To reinforce the fact that Socket.io is a protocol, there is an official protocol specification sitting under this repository in GitHub. And also this protocol is implemented in various other languages other than JavaScript. For example, Java, Python, C++, and Rust, and many others. So one would ask why use Socket.io instead of vanilla WebSockets, and there are plenty of reasons for that. Socket.io is more reliable than WebSockets, and the reason for that is that whenever WebSocket connectivity cannot be achieved because of an old browser version, because there is a reverse proxy or a firewall between the client and the server, then Socket.io falls back to HTTP long polling. Also, there are other features such as automatic reconnection of the client, packet buffering, acknowledgements, message broadcasting, and multiplexing, which we are going to touch upon in a bit. So the caveat is that a Socket.io user, client or server, should never interact with the protocol directly, and they should never interact with they should never care whether it is WebSockets or HTTP polling under the hood. The user of Socket.io should only interact with the Socket class API of the respective implementation library. This Socket class API implements the following symmetrical interface that you see here, and I describe it as symmetrical because it is the same API is implemented by both the server Socket class and the client Socket class. So in the Socket.io protocol, there is not really a server and a client, there is just a sender and a receiver. And the sender can send an event to the receiver using the emit function, and the receiver can receive that event using the handler that is registered using the on function. So again, the on function of the Socket class API registers a new handler for a given event. It implements a subscribing operation, and the callback could potentially return a value that will be sent to the sender party as an acknowledgement, implementing this acknowledgement feature that we already mentioned. The emit function of the Socket class API emits an event to the receiver party, implements a publishing operation, and if an acknowledgement is returned by the receiver, then the acknowledgement callback that you see here as the third argument of the function is invoked with that data. A more advanced concept of Socket.io is the namespace, which essentially it enables multiplexing capabilities. A namespace has its own event handlers and potentially its own dedicated connection. By default, Socket.io uses this single character / namespace, but it is possible for a Socket.io server to set up multiple namespaces, and also to a Socket.io client to connect to multiple namespaces simultaneously. So at this point, where we have only covered the very basics of Socket.io, one would ask, why would we want to document such an API? And I think the answer to that is pretty clear even by now. So here we have a very simple Socket.io server, which in the connection handler we can see that the server emits a few events and also listens to some other events. So on line 4 and line 5 we have the server emitting the hello event, and on line 5 we have the server emitting the greetings event, which is also accompanied by some arguments. The first argument here is just a string, and the second argument is an object, which could be a structured object or it could be like a free dictionary. And then on line 7 and line 11 respectively we have the server listening to the message event, which expects some data as well, and the server listening on the salutation events, which expects an array, a tuple of 3 elements of data. So imagine the client of this Socket.io server being developed by a completely separate organization. We would need the backend team to communicate with the frontend team and let them know about what events does the server support, what events does the server listen to. So I wouldn't want to live in a world where the answers to all these questions would be agreed verbally through some Zoom meeting. There should be a document which stands as the source of truth, and this is where AsyncAPI comes into play. Also bear in mind that we are not interested in Socket.io concepts that are specific to backend, to the Socket.io server. We are only interested in stuff, in concepts that are included within the Socket.io protocol specification. So rooms and broadcasting events is a server-specific concept that is not reflected anyhow in the protocol itself.
Let's now move to the core of the talk, which is about modeling the Socket protocol, the Socket.io protocol using AsyncAPI. So the way I approach this problem is by traversing the AsyncAPI object structure, trying to map each of the objects to a semantic of the Socket.io client API. So I started with the root document object, the AsyncAPI object, which has 4 fields that are of interest to us. AsyncAPI, which is the pinning of the spec version that is being used. We have channels, which are all the available channels and messages for the API. We have servers, which provides connection details for all the server instances of our application. And we have components, which is essentially a library of reusable elements that we can reference across our spec file. So going one layer deeper, we can see the channels object, which is a mapping of channel names to channel item object. The specification states that the channel is an addressable component where messages or events flow through. It enables an application to separate its concerns. To me, this sounds very much like a Socket.io namespace. So there we have our first relationship between AsyncAPI and Socket.io, which is a Socket.io namespace is essentially an AsyncAPI channel. Going another layer deeper, we have the channel item object, which is essentially the values within the channels mapping. The channel item object describes the definition of a Socket.io namespace. In Socket.io, a connection can be established in the namespace level. So the channel item object is the only place in the specification where we can define bindings. And bindings are essentially protocol-specific information for the server. In the case of Socket.io, the bindings describe the handshake context on the connection request. So in this case, we have a WebSocket binding defined for the default channel, for the main channel, where it specifies a schema for the query params. This means that whenever a client wants to connect to that main namespace, they need to provide this token property as part of the query param object, and this token property should be of type string. And this is how it actually happens on the following implementation snippet below, where the Socket.io client establishes a connection passing this query param. There are a few conventions with regards to bindings, which I mainly came up with. One is that we can include bindings under the main namespace, but also we can omit them under the custom ones. This makes the assumption that the custom namespaces will inherit the bindings of the main namespace. However, if a custom namespace includes bindings, then the client should always force a new connection upon connecting to it. By default, a Socket.io client will always use the same connection when connecting to multiple different namespaces. And finally, the WebSocket channel bindings is the only possible binding that can be included in Socket.io API. And one would argue that we could also use an HTTP binding as well, since Socket.io can also be implemented with HTTP long polling. However, this is not possible for a couple of reasons. First is that the AsyncAPI specification does not allow HTTP bindings on the channel item object level. And secondly, is that in Socket.io, the HTTP polling implementation is done in such a way to resemble the WebSocket implementation. So essentially, the HTTP polling is a pseudo WebSocket, and both of the implementation use the exact same handshake object. So it is safe to assume that the HTTP long polling bindings would look exactly similar as the WebSocket ones. However, in an ideal world, we would have the AsyncAPI specification supporting Socket.io as a separate protocol. So the bindings object could have an explicit Socket.io field where one could provide bindings. I have created a GitHub issue in the bindings repository of AsyncAPI to pitch this proposal. So moving another layer deeper,
Next to the bindings field in the channel item object, we have operations which document how and why messages are sent or received. We have the publish operation, which is implemented using a socket.emit call on the client side, and we have a subscribe operation, which is implemented using a socket.on call on the client side, where the client registers a callback for an event to subscribe to. So there we have an extra two relationships between AsyncAPI and Socket.io. So we see that under each operation, either publish or subscribe one, there is a message field which defines a message object. And this is actually defining a Socket.io event that can be published or that can be subscribed to under a given namespace. In this case, here on line 5, we have an event with hello being the event name and payload being the structure of data that can be emitted as part, as part of the emitification from the client. So this tells the client that under the main namespace, they can emit the hello event name using an object that has a foo field, which is of type string. Similarly, for the subscribe operation, the message object is used in a similar manner. So the name of the message defines the event name, and the payload defines the JSON schema that the input of the event callback should adhere to. We have seen, however, in this current setup, we only see that only one message for publish and one message for subscribe can be listed under a single namespace. However, in practice, we have seen that a namespace can support multiple different subscribing or publishing messages. So the way you can achieve that with AsyncAPI is by using this one-off array structure under the message field of each operation. So we've also mentioned that Socket.io provides acknowledgement functionalities. Before diving deeper into how this is achieved in the Socket.io protocol, let's first get some basic understanding of the protocol itself. So the basic unit of information in the Socket.io protocol is a packet, and there are 7 distinct packet types, as you can see on the left-hand side. A Socket.io sender invokes the socket.emit call in order to send an event to the receiver, and the event is conveyed to the receiver using the event or binary event package. Then the receiver acts upon these events using the handler that is registered using the socket.on invocation. The handler may, after it executes, may return or not return an acknowledgement back to the sender. The acknowledgement is sent back to the server using the ACK or binary ACK packet types. Then the sender is going to pass the acknowledgement data into the acknowledgement callback that has been provided as an argument in the original socket.emit invocation. In order to express these acknowledgement semantics, we have to extend the AsyncAPI specification. And AsyncAPI provides a good framework of doing that. So what I propose here is extending the message object to include an XACK field. The value of this field should be a message ACK object that we're going to cover in a bit. Also, the components object may include the XMessageAcks field, where one could list multiple message ACK objects that can be reused throughout the specification file. And this is how the message ACK object would look like. There is going to be an object of a single field, which is going to be called args. The type of this field would be a schema object, and this would be the schema of the arguments that are passed as input to the acknowledgement callback function. And this is how it would look in practice. So, for example, let's take this socket.emit invocation, which is documented as a publishing operation under the main namespace. So this invocation is described using this hello event, which has an event name, which is hello, and then a payload, which describes the schema of the arguments, and then XACK defines the schema of the input that is to be passed in this acknowledgement callback method. And similarly, for the socket on invocation, for the subscribing messages, the xargs schema defines the acknowledgement type that the event callback should return after it executes. So let's move on to the final object, which is servers, which is a top-level object. And this, as we said, defines all the server instances of our application. Each server instances is required to have a URL field as well as a protocol field. From the URL field, we can not only extract the host of our Socket.io server, but we could also get the path to our Socket.io server, which the client can pass when they instantiate a connection to that server, as we see here with that extra path argument. The path defaults to Socket.io, but it can be customized accordingly. Also, there is a protocol field within the server definition, which could be either of WebSocket, secure WebSockets, HTTP, and HTTPS. It doesn't really matter if it is WebSocket or HTTP, but it only matters if there is a secure character as a suffix to that protocol. So the protocol essentially signals the inclusion or absence in TLS for the server. So we made it to the end of this long modeling exercises. Here is a summary. So we managed to establish a lot of relationships between Socket.io and the AsyncAPI. For example, we said that the Socket.io namespace can be modeled using an AsyncAPI channel. The I/O options, the input-output options that the Socket.io client provides upon connecting to a namespace are essentially the WebSocket channel bindings. A socket.emit invocation is a publish operation of a channel item object, while a socket.on invocation on the client side is a subscribe operation within the channel item object. A Socket.io event is essentially an AsyncAPI message, and an event name is the name field of the message object. The arguments, the event arguments, are described by the payload of the message object, which is a JSON schema, and the acknowledgements can be achieved using the XAG specification extension that we proposed. And lastly, we have the custom path to our Socket.io server, which is signaled using the URL field of the server object, and we have the absence or inclusion of TLS, which is using the protocol field of that server object. Let's now get a bit more practical and look into how we can create an AsyncAPI YAML file from scratch, given an existing Socket.io API. For the purposes of this, I picked this minimal chat application, which is featured as an example in the Socket.io website. It is a very simple application where the user enters a nickname to join the chat, and the rest of the participants get notified whenever a user joins, or whenever a user types or stops typing a message, or whenever someone leaves the party. I also put here the full implementation of the Socket.io server in JavaScript. It is not a very complex implementation. It doesn't exceed 90 lines. We're not going to go through each of the lines here in detail, but I put the full snippet here for anyone in case they want to review it on their own time. So let's start putting together our AsyncAPI YAML, and let's start with the simple things first, like pinning the AsyncAPI version, the version of the specification that we want to use, as well as putting together some information with regards to a service like the title, the version, and some brief description of what it does. Also, we're going to have a server section, which we're going to define the server instances of our application. As far as I'm aware, this is an application that is only sitting in a single environment, so we're going to have just this demo server object, which has a URL as well as a protocol field. For the URL, we picked the actual URL that is within the Socket.io website source code, which is this here OcuApp, and it also seems that they are using the default /Socket.io path. In terms of protocol, secure WebSocket is being used. Again, note that it doesn't matter here if it's WebSockets or HTTP long polling. The only purpose of this protocol field is to signal the inclusion or the omission of TLS. So, if here on the left-hand side we have a simplified version of the Socket.io server code that we presented above, and we can see here that the server listens for connections under two namespaces. On line 3 we have the connection handler for the default namespace, and on line 7 we have the connection handler for the admin namespace. So we can identify that we have two channels here, the /default channel and the /admin channel. If we expand the connection handler of the default channel of the main namespace, we can see that there are multiple socket.on invocations. These are essentially the events, the Socket.io events that the server listens for from the client. So we have a new message event that is accompanied with some data arguments on line 5. On line 12 we have another add user event which has a username argument, and we also have the typing and stop typing messages that have no arguments at all, so no event payload is expected as part of this event. So these are the events that the Socket.io client can publish to the server under this namespace. So essentially, these compose all the message objects that we can put under the publish operation in our AsyncAPI schema for that namespace. Similarly, we can also enumerate all the socket.emit invocations we can see with our namespace implementation. So on line 6 we have an emission to the new message of a new message event, and line 13 we have an emission of the user joined event, and so on and so forth. So these events are the events that the client can subscribe to and listen from the server. So essentially, these are message objects that populate the publish operation of the default namespace of the default channel of Aspect. So if we put this together in our YAML, we see that we have our main namespace, which has a publish operation and a subscribe operation, and under each under the message field of each operation, we have all the different messages that are supported. And we achieve, and we of course use this one-off array structure that conveniently allows us to group multiple messages under an operation of its namespace. Now, let's expand the connection handler of the admin namespace. We can see here that the handshake context of the socket is being used. This means that upon connection, the handshake context of the request is being used to extract some information. In this case, a token is extracted from the query parameter object of the request, and some validation is applied on top of that token. This signals us that we should include some bindings as part of the channel definition. So in this case, we have the WebSocket bindings for the admin namespace that put together a schema, a JSON schema for our query parameters object. And this schema has a token property which is of type string, and it is always required. So if the token query parameter validation fails, the socket disconnects. Otherwise, the socket emits an event to the client, which is a server metric. And if you see, actually, if you were paying attention, this server metric event is also listed under the subscribe operation of the admin channel. So let's now move into how we can populate our message definitions within our component section of our schema. And for that, we can expand the add user event handler of the default namespace. This event handler is being invoked whenever a user joins the chat application. So you see here, if the user is already added, so you see here that the inputs of our event handler is a username string and an acknowledgement callback function. So if the user is already added, then a callback function is invoked with an error which says a user is already added. So there could be an acknowledgement of this event by the format of an object which has an error property of type string. So if the user is not added, then we increment the number of users, and then we emit an event to the rest of the clients that are connected to that namespace that a new user joined. And this event has this particular argument structure of a username and number of users. If we are in the happy path scenario, of course, of not having the user already added, then we acknowledge that the user was added and the error of that acknowledgement is of null type. So we can see here that we can populate two message definitions. One is the add user message, which, as you can see here on the second line, it is the message that the server listens for. So it's a message listed under a subscribe operation. So it has an add space user event name and a payload of type string, since the username is the only argument of that event. We also see that within that event handler, an acknowledgement can be returned, and this acknowledgement has this following structure. It is an object containing an error field, which could be either string or null. So we can add this xarg field that we proposed as part of a specification extension, and this args object can describe the properties of the acknowledgement. For example, the error property that would be either string or null. Similarly, we see that an event is being emitted to all other clients, that a user has joined our chat. So we have the user space joined as the name of our event, and then the payload describes this object, which is essentially having a username property and a num-users property, which is of type integer. So now I think we can put together everything into a single specification file. So we see here we start with traditionally with a version of a specification, then we have the info and servers object, and then we have all the channel definition, which is the main channel and the admin channel. And within each channel, we have all the messages under the publish and the subscribe operations, respectively. You see here that the message definitions are actually referenced from the component section of our specification, as you see here. So I've sourced the full, this full setup in a GitHub repository under my personal account. So you can go to the Dedoussis AsyncAPI Socket.io example, which is a repository that includes not only this AsyncAPI YAML file, but also the source code of the Socket.io server and some README to document and instruct someone how to spin up this application. Another benefit that we get for free by documenting our Socket.io APIs is the AsyncAPI Playground visualization, which is a tool that receives an AsyncAPI specification as an input and produces a beautiful visualization of our API as an output. So here we can see all our operations of our API, we can see all our different messages, we can see that some messages have also defined extension. In this case, the add user event has an acknowledgement which has this error type argument. Similarly, we can see all of the different components, all the different messages of our specification, so it's a very nice way of communicating our actual API contract with other teams. So finally, I would like to talk about Asynction, which is a tool that I've been developing in parallel to this modeling exercise of Socket.io with AsyncAPI. Asynction is a Python Socket.io framework that is driven by the AsyncAPI specification. It empowers a specification-first approach when building Socket.io APIs in Python, and it actually guarantees that your API will work in accordance with its documentation. So what Asynction offers in particular? It automatically registers all event and error handlers that are referenced within the AsyncAPI specification. It provides out-of-the-box validation on every Socket.io interaction. This means every incoming or outgoing Socket.io event. And this validation is fueled by the JSON schemata within the message payloads, within the channel bindings, and even within the XAC arguments objects that we previously mentioned. It also generates HTML render documentation similar to the AsyncAPI Playground and exposes it through a separate HTTP endpoint. There is also mock server support when one could spin up a fully functional mock server just used by referencing a local AsyncAPI file without the need of any extra code. There is also a CLI interface, and there is also an authentication feature coming soon, which will be based on the security schemes of the specification. So Asynction was originally inspired by Connection, and hence the naming. Connection is a framework, a Python framework for REST APIs, and it is driven by the OpenAPI specification. On the left-hand side of this slide, we have a very simple OpenAPI specification of a Hello World API, where it has a single greetings name resource. As you can see here in this resource, there is a path parameter called name, and within that resource, we have a single post function. This post endpoint is related to a Python callable using this operation ID field. So the Python callable is actually a post greetings function within the hello.py module. So on the right hand side, you can actually see the the hello.py module, which includes the post greeting method. And this post greeting method takes a name as an input argument. And this is the name, which is the path parameter that we see here in this API resource. Also, this post greeting method returns a string output, and if we pay attention to the response specification of our endpoint, we see that it retains a text plain content of type string. So on the right hand side, going back to the right hand side, we see that it's very simple to spin up a connection Flask application only by referencing a local OpenAPI YAML and then running it as you run any other Flask app. And at runtime, Connection is going to route a request to the appropriate callable, of course, after validating all the input arguments based on the JSON schemata and so on and so forth. So Asynction does the exact same thing, but instead of OpenAPI, we now have AsyncAPI, and instead of Flask, we now have Flask Socket.io. So if we see again the AsyncAPI spec that we put together for the minimal chat application and go to the component section of the spec, we can see that, for example, here in this new message socket.io event, we have a next handler field, which is actually another extension of the specification for the purposes of asynction. This xhandler field relates this new message event to a Python callable, which sits under the app.py module, and it is this new message function. So here, the socket.io client will emit a new message event to the server, and the server will look at this xhandler field in order to call the correct function, the correct Python callable to act upon this event. Of course, Asynction will validate the input parameters that this callable will take, such as the message payload, or it will also validate what this function returns if there is an acknowledgement argument payload that needs to be validated. So here, how it looks on the Python side. Again, it is very simple to spin up an Asynction socket.io server. You only need to reference a local AsyncAPI YAML file and then run the Asynction app like you run any other Flask app. And at the bottom hand side, you can see an example of a simple event handler that can be referenced within the AsyncAPI YAML. So you can find a fully fledged example of how to use Asynction in the Asynction repo under the top-level example directory. This example also uses the minimal chat application AsyncAPI YAML and re-implements it in Python using Asynction. It is also fully documented, so if you're interested about Asynction and how you can use it, I would suggest to have a look there. And finally, another killer feature of Asynction is the mock server, which is also combined with the CLI. So you can install the CLI, the Asynction CLI from Homebrew using brew install Asynction, and then with a single line command, you can just reference a local AsyncAPI YAML file and spin up a fully functional socket.io mock server. This mock server will listen for all the events that are referenced within the AsyncAPI YAML file and return acknowledgements appropriately based on the exec schemata. It will also periodically publish fake events that adhere to the message payloads for any clients that may be connected to that mock server. So we have reached the end of this talk. Thank you very much for attending it. I hope you enjoyed it, and I hope that this talk was not just purposed for socket.io enthusiasts, and I hope it could maybe have motivated others to start modeling more protocols with AsyncAPI spec, or even model protocols that are used internally within your organizations. So once again, thanks a lot, and I hope you enjoyed this. And I think now it's a good time for me to answer any questions you may have.
All right. Great talk. Huh? I loved it. Great stuff.
Thank you. I hope I didn't pack too many things on a single session. I feel it was too much content, but yeah, hope you enjoyed it.
That's always hard to measure, right? Like how much
Yes.
How much content do I put into this presentation? Yeah, I always have the same trouble.
Yeah.
Yeah. So I before in the meantime we wait for people because there's a small delay between Restream and platforms. So in the meantime we wait for some questions. I had a comment on my head, like first of all is like I was surprised by this mock feature. So congrats, this is amazing. I wasn't expecting this. Like I didn't know about it. So that is super cool. We may copy it for Glee.
Yeah,
Give me an idea.
It is a fairly recent feature, but yeah, it essentially uses some other like Python libraries for generating a fake object given a JSON schema, and then for each event it generates that fake object. So it was a fairly trivial implementation. So yeah, I imagine it could be easily implemented in Glee, which is in JavaScript as far as I know.
Yeah. No, actually, yeah. No, with one of the cool things about choosing JavaScript is the ecosystem, right? So and also Python as well. But I mean, and Java, of course. But then, yeah, other languages you might like this. So I understand what you mean. Like, I guess the implementation was trivial for you, but not for whoever implemented the libraries that you were using.
Yeah, absolutely. Yeah, and I guess it wouldn't be a trivial implementation in Rust or in C. So yeah,
Exactly.
thankfully, yeah.
Exactly. That's cool. So folks, if anyone has questions, it is the right time to post them. We still have some time, I guess. Yeah, I think so.
I do realize that there was a lot to digest in the talk. As Alejandra has commented, there is like all the content is dumped into a series of blog posts in the AsyncAPI website. So if you're more interested about this topic, you can certainly check this out.
Yeah.
And
so,
yeah,
Alejandra got a question for you. When is blog post 3 coming up?
Well, not in the short-term future. I mean, these were not really, the traditional blog post. It was, especially the second part, was more of like a reference article on how to document the Socket.io protocol using AsyncAPI rather than going through a story or an experience of mine. So it took a bit of time to write it. So I feel I covered the foundations of it. So most likely there's not going to be a third part anytime soon.
All right. And I got a question myself. So from my experience building Glee, Modelina was key for that, like being able to generate data models, classes or models, call it whatever you want, on runtime, or let's call it on runtime in the beginning. Let's say in the beginning of the runtime, right? So I was wondering, like, if you implemented something like this on your library, like how is it managed? Or is it, or you're using any feature, like here can be any object or something like that, whatever it's on Python.
Yeah. So for the context of sorry, I can hear my echo myself echoing.
Sorry, it's my fault.
That's all right. So for the context of the crowd who is not familiar with Glee or Modelina, Glee is like a similar framework to Asynction, which essentially it's a specification first framework, which is not just for WebSocket, but it attempts to solve the problem for a big amount of protocols, rather than just Socket.io or WebSockets. And Modelina generates, I think it generates JavaScript classes, or actually not just JavaScript, or also Java or other languages classes from JSON schemata. Correct me if I'm wrong.
Yeah. No, you're right.
So there is this, at the moment, Asynction passes and not serialized serialized data to the event handler. So it doesn't takes a JSON payload and structure it to a Python object. It just passes free dictionary. However, there is an item in the roadmap of Asynction to use existing Python libraries which take some unstructured data and puts it into a class. Or generate classes based on your JSON schemata and then use these classes at runtime when you pass the data to the event handlers. So yeah, it's in the roadmap, but probably not coming anytime soon. Same as blog post number 3.
Just one last comment from myself. So there is a experimental functionality on Glee that that actually Jonas and I were working on, and we were implementing support for Java. So you could write your code in Java, even though the framework is written in JavaScript, but your code could be in Java, and it will take care of running Maven, whatever you need, and it will execute Java code, right? And it's done in a way that we may be able to augment this to different languages, and so Python can be one of them, right? Like, so I don't know. Take a look at this, because maybe there's a way to augment this with Python.
I have had a look at Glee, and I found it very interesting. And unfortunately, I didn't have the time to contribute to it. But yeah, I would love to see Glee coming at a point where it can support Python, callables, or any other language, so I can sunset asynction. So yeah, if we get to this stage, then yeah, I cannot see why both should exist. Like I think Glee can cover the entire domain of asynction, hopefully.
Just, I mean, with this, I don't mean that you should sunset asynction. I think it has, you know, it has a point there. It is socket.io specific, so that is actually sometimes it's cool that you have a library that is specific to the stack that you're using, and that's perfect. And you will be able to cover more specific features than a generic one, right? Like a generic Glee or something like that. Glee is more generic.
But similarly, the original vision of asynction, I mean, the first practical application was socket.io, but I was also imagining to support other protocols in Python. So I think Glee covers this, you know, protocol agnostic domain, but also the language agnostic domain. So it's a superset of asynction. So
not yet, but we're gonna try.
That's yes, exactly. Yeah.
Cool, Dimitrios. So we have no questions, I think. Let me just check on Slack. Yeah, no questions so far. So thanks a lot for joining us, and hope to see you around, and still see you around for a while.
Thank you very much for having me, and I hope you enjoy the rest of the conference as well.
Thank you. Bye.
See ya. Bye.
Okay, folks, so we're going to do a very brief break, or I was just thinking maybe we shouldn't do the break because it's just 4 minutes. So maybe we just invite our next speaker, and so Dale, who is waiting already in the backstage. I can see him. Hey, Dale, welcome. Hello. I love the website that you have in the background. What is that? It is AsyncAPI on your...
Oh, I stole your design for my slides.
I love it. So Dale, please introduce yourself for those who don't know you.
So my name's Dale. I'm a developer for IBM. I work in what we call our client engineering team, which means I work on proof of concepts and proof of technologies and prototypes, things to help customers get started with our tech. So I spend a lot of my time working with things like Kafka, a lot of my time looking at how we do integration projects and how we scale integration. So I spend a lot of time recently sort of thinking about how we use AsyncAPI.
Awesome. So so Dale is going to be speaking. It's a lightning talk, just for you to know. It is just 10 minutes, I think.
Yeah, not even that.
Even less. Oh,
yeah.
Amazing. You managed to peg it. So he's going to be speaking about describing Kafka security in AsyncAPI. And yeah, I think we should just go ahead and play the recording, and then we can chat again. How does that sound? Cool. See ya. Bye.
Welcome to this session about how we describe Kafka security in AsyncAPI. My name is Dale, I'm a developer for IBM, and I'm a new member of the AsyncAPI Technical Steering Committee. When I say security, there are two aspects I'm including in this. Encryption, are you using SSL TLS for your connections to Kafka? And authentication, do you need credentials for your connections to Kafka? And I'm going to cover this in both directions. Firstly, writing an AsyncAPI document. What I mean is, how do you go from a configured Kafka cluster to writing an AsyncAPI document that describes it? And secondly, using an AsyncAPI document. So by that I mean, how do you use an AsyncAPI document to configure a Kafka client application? But like I say, let's start with how do we go from a configured Kafka cluster to writing an AsyncAPI document that describes it. As I said, I'm going to cover both encryption and auth, but first let's start with encryption. We describe this in the server protocol section of the document. So if your cluster isn't set up to use encryption, then you just use protocol Kafka. If your cluster is set up to require encrypted connections, then use the protocol Kafka Secure. So no encryption, use protocol Kafka. Encryption, use protocol Kafka Secure. So that's encryption sorted. Next, let's look at how we describe the authentication setup. If your cluster is set up so there's no need for authentication, that's easy. You just describe the server like this. If authentication is required, then you need to add a security section to the server definition. And then the presence of the security value is what's telling you that authentication is needed. The type value in the matching security scheme tells you the authentication mechanism. These are the security scheme types in AsyncAPI that you can use with Kafka. Plain for SASL plain, Scram-SHA for SASL Scram in both the 256 and 512 variants, OAuth2 for OAuth bearer, GSS API for Kerberos, and X509 for mutual TLS. Let's look at a few examples of what this will look like. So, if your Kafka cluster is set up without encryption, but using SASL plain for authentication, you would describe it like this, using the protocol Kafka and the security scheme type plain. Or, if your Kafka cluster is set up to require encryption and using SASL Scram 256 for authentication, you would describe it like this, using the protocol Kafka Secure and the security scheme type Scram-SHA 256. One last example. If your Kafka cluster is set up not requiring encryption, but using SASL Scram 512 for authentication, you would describe it like this, using the protocol Kafka and the security scheme type Scram-SHA 512. So that's how you write an AsyncAPI document that describes your Kafka security. Next, let's look at this the other way around. How do you use an AsyncAPI document to configure a Kafka client application? I'm going to go through a few examples, and for each one I'll show you a couple of different ways of configuring a Kafka client app. Firstly, values in a properties file, and that's the most common way of configuring a Kafka app. And secondly, I'll show you how to do it programmatically using Java as an example. So let's start with the simplest document, protocol Kafka. So remember that means no encryption, and no security scheme. So remember that means no authentication either. So you'd configure your app for this using security protocol set to plain text. And in Java, it could look like this. You would put your security protocol config set to plain text in the properties object that you'll pass to your Kafka app. Let's try another example. In this one, protocol is again just Kafka. So again, that means no encryption. But this time there is a security scheme, so that means we are using authentication, and the security scheme type tells us the SASL Scram mechanism we need to use. So the security protocol we would use in our app this time is SASL plaintext. The plaintext bit is because there's no encryption, and the SASL bit is because we're using auth. And then the SASL mechanism identifies the auth type. And in code, using Java as an example, it would look like this. SASL plaintext for the security protocol config, and Scram-SHA 256 for the SASL mechanism. Let's try one last example. In this one, the protocol is Kafka Secure. So remember that means encryption, and there is a security scheme, so that means there's also authentication, and the security scheme type is telling us which SASL Scram mechanism to use. The security protocol we would use in an application for this is SASL SSL. The SSL bit because there is encryption, and the SASL bit because we're using auth. And then the SASL mechanism identifies the auth type. And in code, it would look like this. Again, SASL SSL for the security protocol, and Scram-SHA 512 for the SASL mechanism. So hopefully you get the idea. The server protocol and the security scheme type tells you everything you need to be able to configure a Kafka client application, everything except the credentials themselves. And to sum up, here is the full list of all the possible server protocol and security scheme type values, together with the corresponding Kafka config properties. There are some blank cells here, so these are where you don't need to set a value. So for example, if there isn't a security scheme type in your AsyncAPI document, that means you don't need to set security.protocol in your Kafka client application. There are a few tools that I'm aware of that understand what I've gone through. So if you use the AG, the async API generator, it can generate Markdown, HTML, or Java code with the right Kafka config based on what is in your async API document. The URL for the plain vanilla Java template, it's a bit different because this is a new template that we just created for the hackathon, and we're still in the process of contributing it to the Async API org. Other than that, it works just the same as the others, and I expect this is going to be moving pretty soon. And if you use the Node-RED Async API plugin, that will configure security for Kafka nodes in the same way that I've been describing. So thank you for listening, and I hope this was helpful.
Awesome. Straight to the point. Love it. I love it. So like I've been saying, we have some delay with the streaming platforms, right? So we're gonna wait for folks in case they have some questions. In the meantime, I have a thought that I want to share with you, and is that, or maybe a question. I don't know. I don't know yet if I'm gonna ask a question or just share the thought. So you said when so the protocol is Kafka secure, then the encryption is SSL, right? If I'm not mistaken.
Yeah.
I think so, yeah. So then it came to my mind, and I think you mentioned once, but I'm not sure, that maybe we should decouple this from the protocol part, like we should be able to specify the protocol and then separately say like, hey, I want to encrypt using SSL or encrypt using something else, encrypt the connection, of course. I don't know. Don't expect a response from you. Just
so part of the problem is that Kafka blurs the lines a bit. So the security protocol is used to tell you if it's SSL or not, but the way you describe it's SSL changes depending on whether or not there's author authentication involved. So there's SASL SSL and SSL, which is encryption and encryption plus auth. So I think, yeah, there's a bit of a overloading of the term, but I think that's something we inherit from Kafka.
Yeah. And I guess it will be the same for the rest of the protocols, like I don't know, like HTTPS or WSSS, one less S, and MQTTS. I think it's not MQTTS. Actually, I think it's secure MQTT or something like that.
It's that we're trying to mirror here. So as far as async API is concerned, I think we just keep Kafka secure means encryption. And it's only when you have to start mapping that to Kafka settings that you need to know that it's a little more complicated than that.
Do you think there will be, there will be another way, like for instance, Kafka secure means SSL encryption, but do you think, is there a possibility that we could mean now or in the future that the encryption is different? It's not SSL, it's using some other type of encryption?
Don't know. Maybe. I mean, we always say SSL when we don't really mean SSL anyway. So I'd imagine we're stuck with it now. We're gonna keep saying SSL whatever the encryption is.
Yes. Okay. Sounds good to me. Yeah. Cool. We don't have questions, I guess. That is a very specific topic, right? You need to be hands-on, really hands-on to this. But thanks a lot, Dale, for joining us. I want to apologize to the audience that I started your talk, I think 2 minutes before the time. I got stressed because we were going late. We were coming late from the previous talk, and then I was trying to compensate. But yeah, we shouldn't start before, just in case someone is joining at the right time, right? So yeah, apologies for that. And I was not respecting the break as well. So yeah, apologies for that as well. Cool, Dale. See you around. Thanks a lot for your contributions, not only on the conference, but to the spec and to the project. And see you around.
Yep. See you later.
Bye. Okay, folks. So as promised, and as I said just now, we're gonna start a break. Where is the break video? Lucas, do you have the break video maybe that you can play? Thank you. All right, welcome back, folks. I hope you enjoyed this break. Short break though. So next talk is AsyncAPI is here to stay. Whoa, what a statement! I love it. Learn how to apply it in your projects with the API first approach, and it's done by Rolando Carrasco and Leonardo Gonzalez from SPS. Let me invite them to stage. Welcome, folks.
Hey, how are you, Fran?
All good. How are you? Do you mind to introduce yourselves? Maybe speak a little bit about you?
Yeah, sure. So first of all, thank you for everyone who is here in the conference. I'm Rolando Carrasco. I'm from Mexico. And well, I'm from SPS, consultant of API management and distributed systems. And that's me. Thank you, Fran.
Hey, Fran. My name is Leonardo Gonzalez. I'm from Mexico City also. So I'm glad to be here. This is my very first time talking in this conference, so we are excited about it.
Thank you. So you're very much welcome. I love to see more Spanish-speaking community. I love it. So as you may know, I'm from Spain, and we have Alejandra in the chat, who is also from Mexico, and saying bienvenidos. So yeah, I don't want to spend more time. I'm gonna play your talk now, and we'll have a chat afterwards. Okay, we'll have some questions afterwards.
Good. Thank you.
Thank you, Fran.
Welcome.
Thank you. Thank you for having us. We are very excited to be here in the AsyncAPI conference. We are Rolando Carrasco and Leonardo Gonzalez from Mexico. We are part of SPS, which is a consulting firm here in Mexico. We are in the second day of the AsyncAPI conference, November 17, and we are here to talk about the relevance of the API first approach together with the AsyncAPI specification. And this is the agenda for today. We're going to start talking about the relevance of the APIs in the digital transformation era. We are going to question ourselves about the challenges of describing APIs on event-driven architectures. We are also going to describe which elements we need to include or incorporate in APIs around EDA. Then we are going to highlight the value of mixing the API first approach with the AsyncAPI specification. And then we're going to finalize our session with a real life scenario. And then we're going to give some conclusions, all right? I am Rolando Carrasco. I am here with Leonardo Gonzalez. We are both part of SPS Solutions. As I already mentioned, it's a consulting firm. We are focused on API development and design and other things using different technologies such as MuleSoft, Oracle, and some others. And if you want to contact us in the future because you like this session or you have any questions around it, these are the right channels where you can find us, either LinkedIn, email, or Twitter, all right? So this is a brief summary about my career. I started in Lycos.com back in 2000. You can remember Lycos as one of the first search engines in the web. Then I joined Hewlett-Packard back in 2001. And actually in Hewlett-Packard, I started my career in terms of integration technologies. And then I moved to Oracle in 2002 and continued with that integration technologies and SOA and all those things back in the 2000s. And then at the end of the 2009, 2010, I started my own company, SPS, and we are focused mainly in integration platforms and API technologies and modern architectures in general. And I like, as my hobbies, to collect old-fashioned video games, and also I run a brick and mortar store here in Mexico City. It is a pop store. We sell vinyl toys. So pretty much that's myself. So Leo.
Yeah, thank you, Rol. So thank you for being here in this session. So some of my technical background, I started programming Java back in 2003. I used Java, Struts, Hibernate, and so on. I also designed some stuff using UML. And then I jumped into the integration world. I moved into integration architectures, some backend stuff, web services, and finally APIs. I used SOAP, of course, now REST services, and different technologies such as Oracle SOA Suite, now more modern technologies such as Docker containers, MuleSoft, API-led connectivity, application networks, and so on. I'm an enthusiastic of craft beer, so I opened my own bottle shop, and I'm running right now a tasting room here in Mexico City. So if you are around the city, just contact me, and you are very welcome to this place.
Good. So let's get started. This is our first slide, and we want to start with it. And we've been starting our presentation in the past years with this very same slide because we highlight the relevance of the APIs in the digital transformation era. And we say that the digital transformation turned us speechless, and we are thanking the APIs for that. And we are saying that because if you think about different activities that you used to do in the past and you compare it on how you are doing it now, for example, a web check-in for a hotel or an airline, or asking for a Uber ride, for example, you will find a lot of differences, and you can do all those activities without the need of talking with someone, without having a conversation with a person. That's what I'm trying to say, because of the way those applications are built. And part of the success of those applications is because they are somehow driven by APIs. You as a user, you are not aware that you are calling a specific API every time that you do a check-in to your hotel or an airline. But at the end of the day or behind the scenes, most of those applications are interacting with APIs. So I think we are surrounded by APIs, and those APIs are enabling us to do activities in such a way that we probably don't need to talk with someone. And I am not highlighting that we don't have conversations with persons, but what I'm highlighting is the impact that those APIs have. So that's the point.
Yeah, and the question that comes to my mind is if we are living in a happy world, in a world that are surrounded by APIs. And if we take a look on some websites, these are some cool websites. The first one is the Programmable Web. It's an API directory. Here you can search over the 24,000 APIs, public APIs, and much more. Some news about the APIs and so on. This morning, I received this report from Postman about the APIs, and it's funny because we are going to talk about the APIs. We are going to talk about the API first approach, and I received this morning. And the conclusion for these years is that the pandemic changed the world, and the world responded with APIs. So that is a cool thing, because our job is to create API. So that is cool for me. Secondly, the API ecosystem is global and growing up. So it's not only one country or a small amount of countries, but the APIs ecosystem is all around the world. So that is a cool thing also. The third thing is that the developers are spending more and more time with APIs, using APIs. The companies are investing more money on the development of the APIs, and the quality is the top priority for when we are thinking of APIs. And more companies are embracing the API first philosophy, which is a thing that we are going to cover in this session. It's a cool thing. And the seventh thing is that being API first pays off. So it's worth it. So we need to spend more time designing APIs and thinking in APIs. What do you think, Rolando?
Yeah, it's very good information what you just shared, Leo. And also we can highlight that the relevance of the APIs in the world, in the economy itself, with some very specific examples. So if you think about top 10 fintechs in the US, for example, this is a report from Forbes. And I would like to highlight two things. The first one is that, for example, these fintechs companies are API-driven companies. So most of the times they are using APIs from third parties, and they also offer APIs for their customers. So they are API-driven companies. And if you see, that's the first thing that I would like to highlight is the value of those companies. Stripe, for example, is a 95 billion US dollars company. So that's a lot of money. That's a lot of value. And the other thing that I would like to highlight is that they are run by very young people. So if you take a look to the CEOs of those companies, it is very young people, right? So as you can see, the APIs is just not a matter of a technology thing. It is a very relevant thing for the economy. And actually it is somehow driving, or the economy is somehow driven by them. So we are talking around a very relevant topic now.
And what about APIs when we think in an event-driven architecture? So probably you wonder if you can describe APIs that support this type of architecture. And the answer is yes. There is a thing called AsyncAPI where that you can use to describe this type of APIs over this type of architecture. So we are going to cover this syntax or this specification more in detail. But yes, the answer is yes, you can define APIs even if you are using this type of architectures.
Yes, and some of the challenges that we identified, and that's why we raised this question, is that can we describe by an API those different events, channels, subjects of an EDA architecture? So you may be wondering that. Obviously, we are here in the AsyncAPI conference, and that is the answer for that. But previously, before AsyncAPI, the question is, can we describe it? Because we normally think about APIs with normal HTTP, synchronous calls, etc. And it is pretty easy to identify how can we describe them. But what about events? Okay, it can be challenging, definitely. And the challenge is because we have a diversity of messaging systems. So it is very common to have Kafka or RabbitMQ, JMS, AWS SQS, and so on, in order to communicate our systems, in order to produce events. So that's the challenge, that we have a very large diversity of messaging systems.
Yeah, and we normally care about the implementation stuff, such as messages, protocols, and deliver policies and so on, but not about the specification. It's normal because we are developers, so we think about the code. But it's a very important thing to take care about the specification itself. For example, if we take a look on this picture, we can see that we are using for this architecture a Kafka broker, and we start thinking how to connect with that Kafka broker, how to send a message to that broker, how to retrieve a message from that broker, what is the bootstrap we need to use. What about the transactions? Can we use a single transaction? Should we use a single transaction or not? That are the first things that comes to our minds in this type of architectures. But we don't care about the specification, and that is not a good thing at all.
Yes, and as you mentioned, Leo, we will normally ask for the SDKs. That will be our first speech, if you will, about having this type of diagrams. And we are, let's imagine that we are a group of developers and we need to solve the situation that you just described in the previous image. The first question maybe will be, okay, so I am going to use a consumer which is based on Java. So what is my SDK in order to consume that message? So we normally go into that direction before thinking in the specification itself. So what we are trying to do in this session is to take you to this scenario about the relevance of having that specification and the relevance of writing that specification before anything. So as with any other architecture, like, I mean, technology or any other type of architecture, we need a way to design, okay, what we are going to build. So we need to represent what we are going to build. And it is better to have it first. So every time you build a house or whatever, you have the blueprints for that. That's the first thing that you design, right? So it is the very same thing now.
So here the idea is that we need to create the specification first, which is the API first approach, and then code something. So first of all, we need to create a specification that will be solid and that will remain useful for the developers over time. So not only today or tomorrow or in the next month, but over the time. So that is when the API first approach comes to the rescue. And what exactly is this thing? So we need to plan some stuff. We need to get some feedback first. We need to refine our API specification, and then we can think about the code.
Yeah, so before getting into those details about how to connect to the messaging system, it is better to describe those events that are going to be happening within your architecture. So just think about it for a minute. So if you first describe that something is going to create an event, now whoever is going to produce that event is going to know the event that is, how the event that it is described. And the persons or the application that needs to consume that event, the message of that event, then they know the structure and the protocol and ports and channels and whatever, right? So that's the value for that. So all of that is clear, but again, we are talking about events, right?
Yeah. And here is where the API first approach and the AsyncAPI, get together and work together. So how can we combine these two things?
Yes, this is the value. We try to summarize some of the values for doing that mix of visions, the API first approach and the AsyncAPI specification. And modern architectures and modern development are driven by events. So it is pretty normal to have events in our application. So if you don't use AsyncAPI to describe your specification, then you're going to struggle a little bit to share what your component is going to publish, and then to share what others needs to use in order to consume those events. So the value for that is what we are trying to highlight here. And it doesn't matter if it is events or they are not based on events. The API itself has this essence of describing what you are going to build. So it doesn't matter. What I'm trying to say is that you can keep doing what you are already used to do in order to describe your normal REST APIs, but now think about it with the event-driven architecture. And if you get the value from the event-driven architecture and you translate it to an API, then we are going to show you how powerful it is. Okay, so what do you typically start or what do you do in order to document an event-driven architecture, Leo? What's needed?
Yeah. We need to, as you mentioned before, we need to document something. We need to create the specification itself. So in an event-driven architecture, we need to describe what the servers are, what protocols are we going to use, what are the URLs, what are the channels, what are the operations, are we going to publish messages, or are we going to subscribe an application to a queue or to a topic, and so on. What are the structures of the messages that we are going to interchange in this architecture? So all those things are available in AsyncAPI, and you can describe different servers, different protocols, different channels, different type of operations, and different message structures. All those things are available in the AsyncAPI specification to create our particular APIs.
Yes, so now let's move to the real world scenario. So this is a pawn shop where customers bring their goods to be evaluated. So we have an agent or a person in the pawn shop who is in charge of evaluating the goods that the customers present to them. And every time this person accepts the good and makes an offering to the customer, and the customer accepts the offering, the information of that transaction needs to get into different applications, such as the accounting system, the scoring system, a CRM, a risk management system, and then also they need to publish that information in a real-time dashboard, in order to get to know how well the business is running in the different branches of this pawn shop. So as you can see, there is an event that needs to get produced within that transaction, and there are other applications that are interested on that event. So it seems to be a very straightforward scenario for us, right? The infrastructure, or from the infrastructure point of view, we have RabbitMQ for the message broker, the pawn application, or the pawn shop, the pawn shop application, or the POS. It is based in Java. We have a risk management solution, which is based in Oracle BPM suite. We also have the scoring system, which is a Java-based system. Accounting is .NET. CRM is Salesforce, and the real-time dashboard is based on React and with a Node.js backend. So we have a diversity of technologies. We have the POS in Java and the rest of the technologies with a different platform.
Yeah. In this example, in these real life examples, we need to describe, or we need to identify and describe some elements for our APIs. So these are the elements that we already identified for that real life examples. For example, we have one event to get described, the good, which was accepted by the pawn shop, and then we need to produce a message. Who is going to produce that message? Well, the POS application will produce a message once the good is accepted to the particular channel that will make available that information for the interested system. So we already identified these elements. We need what do we need to interchange, which is the good, or the information about the good, who is going to produce the event, and who is going to consume the event. So in this case, for example, the application interested in this type of event are the CRM, the risk management systems, the scoring systems, and so on. All the systems we mentioned before are the applications that are interested in this type of application. So let's identify some differences from the point of view of using an EDA or not using an EDA. In this case, what happens if we don't use an architecture of this type, Rolando?
Yes, let's imagine that we don't use EDA for this, because it is very clear. The POS is going to create an event, and then we have multiple applications interested on that event because they need to process that information, right? But just let's imagine that we don't produce the event and we don't use a message broker for that, and that the POS directly needs to deliver the message to those different systems. So probably the owners of those different systems are going to describe different APIs so the POS can connect to them, right? So at least in this case, we have 5 different APIs that we need to describe and we need to develop, which is not bad. We're just talking about 5 different APIs and probably a very small group of operation for this very use case, yes? But let's imagine that you need to add an additional system. The POS will need to understand a new API in order to connect to that specific system. Or if a system changes, okay, so changes for some reason, then we need to incorporate those changes for the POS and so on. So that's the main difference. In this case, for the EDA architecture, we are just going to describe one single API, and in the other hand, we will have to describe 5 different APIs at least. So you can see the value for this, and you can see the difference.
Yeah, so let's take a look at the API we described for this real scenario using AsyncAPI notation. So let's have some fun. If the good news here is that AsyncAPI provides a playground that you can use to create your specification. It has a lot of cool things. For example, every time you change your specification here on the left of the screen, the playground will auto-generate the documentation for that API. So you will see reflected the documentation updated in the right side of the screen. So that is a cool thing. It's a visual way to see what are the parts of your API specifications. So when you open this thing, AsyncAPI Playground will provide you with a sample API, which in this case is the Streetlights API. But we already write our API using this syntax. This is based on YAML. So it's easy to read, it's easy to write, is easy to start describing your API. For example, in the first section, we have the information, the general information about our API. This is a pawn shop service. This is the version 1.0.0, and we have a description here about what the API is going to deliver to the developers that are going to use this API, okay? We have some channels. In this case, we have a channel called Goods Evaluated. This channel is to use, you are going to use this channel when you need to interact with the evaluated goods, as we mentioned before in the real case scenario. If you need to process some information about the evaluated goods, you are going to use the subscribe operation. If you need to publish or to produce some messages about goods that has been evaluated, you are going to use the publish operation. All that documentation is reflected here in the right side of the screen. In this case, we have the subscribe operation, and we have the structure of the message that we are going to interchange or that we are going to push to that channel, okay? In the documentation, we can see that we have information about the customer, in this case, the number ID and the full name. We have information about the branch ID, the name and the city. And we have information about the items or the goods that is going to be evaluated. In this case, we have the name of the good and the description of the good. And finally, we have the total amount of the loan that represent the value of all these goods that are received or that the pawn shop received in the POS. So we can describe everything here, and we will see the documentation here. It's a fun thing to start playing with the AsyncAPI and to describe this type of architectures. So this is how the playground looks like in this case. And Rolando?
Yes, so we're going to start concluding our session, and the main purpose of this was to highlight how to get value from the API first approach together with AsyncAPI specification within an EDA architecture. So as you can see, one single API, it is used to understand what is going to be published. And if you are interested on that event, just consume the message, and that's it. So that's the power of this. So remember, just one single API, just describe the event, and you get to know how it's going to get published and what is going to get consumed. If there is an additional consumer interested on that, you don't need to modify anything. You don't need to mess with the others because something changed in that new system. You can continue using the very same API and incorporate as much consumers as you need. If you change the message for some reason, then all the systems are going to get impacted, but probably they can beforehand know that those changes are going to happen because of the description in the API. So it has a lot of value, and hopefully we are transmitting this message for you. And as I mentioned, if a new system is integrated, the specification remains valid. Okay, no one needs to make any type of change. So I was forgetting that message, but that's very relevant. Okay, Leo?
Yeah. Just to finalize this session, we can recommend that describe the API first and then start coding. But be sure that your API is solid. Be sure that your API is gonna be useful for the developers that are going to use these features or this information about what you are publishing using this type of architectures. And also take a look on the Postman report about this. Why this API first approach is very important, not only for us as developers, but for the companies. This is a very important approach. It has a lot of information about real cases in the world, that companies that are implementing this type of approach in his API initiatives. So that's pretty much what we have for you guys.
Yes, thank you, Leo. So if you have any questions, we can answer them. If you want to contact us, we already share with you our direct channels to either LinkedIn or email. So as we started with this session, we are very happy to be here. We're very pleased to be part of this agenda of the AsyncAPI conference. And thank you. Thank you very much.
Thank you, guys. Bye.
Bye.
Well, thank you a lot for this great talk, Rolando and Leonardo. We have some delay between the stream, the platform that we're using, we're connecting ourselves, and YouTube and Twitch and other channels. So we're gonna wait for your talk to finish there. It's just a few seconds, right? And I hope people start asking questions. And we have no questions yet, but we have Alejandra showing some love. So yeah,
Thank you.
I think that is universally understandable, I guess. This is basic Spanish. So,
yeah, hopefully the people like it. We tried to make it short and try to deliver a message very straightforward, so hopefully it was accepted.
I think the message, like why API first is important is, it's an important message to transmit to the audience, right? Like, it is funny, at least for me, that I've been into APIs not for so long as you, maybe just I don't know, like 6 or 7 years, something like that. And for me, there's no other way. Like, it has to be API first. Like, once you go API first, there's no other way, right? There's like, you get used to that, and you see the benefits, right? But for some reason, this is still not adopted, let's say, widely in the engineering community, right? Like, people prefer to start coding, and then, definitions are something that we'll take care about later, right? Which is, sorry, I think it's a lot related to the tooling that we have, the lack of tooling sometimes, right? And that, yeah, and the status quo of the tools that we've been using for years, right? Like if the tools that you've been using for years don't follow the API first principles, then you probably won't be migrating your code just to change that, right? And then, yeah, that's the problem, right? Like it is hard to, it is a resistant path, right? Like it is really resistant path. So yeah, you have some more love on the chat from Brenda.
Yeah. Yeah, she's part of our team. So thank you, friends.
Okay, so I guess we have no questions so far. If you know, if you want to drop some questions even later, we have the conference 2021 channel on our Slack workspace. Also, Rolando and Leonardo shared a way to contact them. So feel free, I guess, as they said, to reach out to them and ask questions, right? And thanks a lot for joining, folks. And we're gonna do a short break now, and we'll have another Mexican joining us, Alejandra.
Oh,
Bye
great.
bye.
Thank you.
That's good. Thank you. Thank you, guys. Bye.
Bye.
Hello. Welcome back, everyone. I hope you had time to go to the toilet and accommodate yourself for the next guest, for the next speaker, the one and only. The oh no, it's my talk. Damn. Okay, let me invite Alejandra to the stage. Hola, Alejandra.
Hola.
You said you don't allow trolling.
Me?
Didn't you say that? You don't want me to troll you in public?
Oh no, I just said I didn't want you to judge my face, how it looks this morning. That's what I said.
I didn't say, you said.
Oh my goodness.
You trolled yourself.
Well, I can't say anything now because we're live, but later we'll see what happens.
All right. So let me explain what happened. So we had I mean, Lucas already explained, but for those joining now, we had a talk from Deva Jena from PayPal, and but he couldn't make it, and so the community, including myself in this case, reacted, offering to replace his talk, his slot, with another talk. So I offered my talk, a talk that I already recorded a few days ago as well, actually last week, and it's about designing event-driven architectures. But I mean, you were supposed to introduce my talk. Sorry. And I wanted to mention that not just myself, but also Greg Meldrum from Solas offered another talk for tomorrow, for the last talk tomorrow, which is also going to be cancelled. And that is super cool. That means that we have a responsive community, and yeah, we're gonna have finally, we're not gonna have empty spots or empty slots, right? We are gonna have actual content, and that is super cool. So now the stage is yours.
Are you speaking to yourself again in the third person now? But
I can be here.
Everyone,
Hello,
I just
Fran.
wanted to introduce Fran.
How are you doing? We can be speaking like this. That would be hilarious.
Yes. Do you still want me to? Yeah. Okay. I'll say something quick. Hello, everyone. I'm so happy to repeat what Fran just said. Where I welcome Fran to the stage, where he's already been on the stage. And he's here to talk about design event-driven architectures using the AsyncAPI specification. And in case you haven't found out yet, he is one of the co-founders of the AsyncAPI specification. So hopefully he knows what he's talking about. So that's how I'd like to introduce him. And we're excited to learn from your presentation.
Thank you. Let's chat later as well. You stay here, right?
Yes, sounds good.
Okay. See you later. Bye-bye. Hello, everyone. Thanks for attending my talk on AsyncAPI and how to design event-driven architectures. Today, I'm going to speak a little bit about what AsyncAPI is and how to build an event-driven architecture, and I'm going to do a demo of it. You'll see soon. My name is Fran Méndez. I am the creator of AsyncAPI. I'm currently working as a director of engineering at Postman. You can find me on Twitter and on LinkedIn, and also send me an email if you want. I'm always as responsive as possible. So yeah, feel free to reach me out. So what is AsyncAPI? AsyncAPI started as a specification in the beginning. The purpose was to define and design, document and design event-driven microservices. Then it went well also for Internet of Things API and for streaming APIs in general, right? And pretty much any system based on messages. So I want to make clear that the specification is protocol agnostic. That means that it's not for Kafka, this is not for MQTT, this is not for WebSockets, it's for any kind of protocol. So actually it has some mechanisms to let you define protocol specific information, whatever protocol you have, even your in-house, built-in-house protocols. We also develop a bunch of tools, really a bunch, to help you out with this, because we think that a specification without tools is just a document, right? A piece of paper if you want. So we want to provide you also with the best tools possible to work with the spec, right? So go to the website asyncapi.com and you'll find out a lot of, about a lot of tools. Like we have Studio, which is right now in beta, really cool. Generator, which is capable of generating code and documentation, and a bunch more you'll see. As I said before in the beginning, I don't for this talk I didn't want to talk so much, and I preferred that you see a demo of myself. So I'm gonna just jump into a demo, and you'll see how I'm using AsyncAPI to build event-driven architectures. All right, so the demo is about creating a social network, like a very basic social network. Just for reference, I'm gonna show you how it will look like, more or less. This is a front end that I already created and looks somehow similar to Twitter. So this is the profile of the logged in user, and these are some publications or some tweets or whatever you want to call it. And just so you know, we have user 1 here. So we're just hard coding the users. And we have user 2 here, which is my friend Lucas. And he can see exactly the same publications as I do. There are only publications from me and him, basically. Cool. So how did we build? Just for the reference before I continue, you can see this is failing. Firefox can't establish a connection to the server. Blah blah blah. Of course, because that's only the front end. There's no back end yet, and that's what we are going to be working on right now. If I click on like, you see that it does nothing on the front-end stuff, but it doesn't count. Cool. So let me get back to the diagram. So this is more or less the architecture that we're going to be creating right now. We have the browser already done, the front end already done. So the browser is going to be communicating with a WebSocket server, and the WebSocket server is going to be either replying to the browser with some events. Replying. I don't like to say replying in this context. It's not a reply. It's going to be sending and receiving messages from the browser, and some of them are going to be forwarded to an MQTT broker. For this demo, we're going to be using Mosquito Test Broker. It's easy and it's ready to use. And we have a notifications service here that is going to be listening for a specific kind of events. And whenever it's received, it's going to send a message to Slack. So just so you see it, it is, just so you can see the full picture, is whenever we hit like on one of these buttons, on one of these publications, as an event is sent to the WebSocket server, and it's forwarded to the MQTT broker, which then reaches the notification service saying that someone has liked a publication. And there's some bit of a logic there. Depending on if you're liking your own publication or others' publication, it might send or not send a message to Slack, a notification to Slack. Cool. So that is it. I think that it's we have the stage set up. So let's get started building our backend. Let's start with the WebSocket server. As you can see, I have the front end here. We're not gonna get into the front end. This is a Next.js app built with React. That's, I would say, a very basic one. And for our database, we have this db.json file very rudimentary, but for the purpose of the demo is more than enough. So we have our users here, we have Fran Méndez, Lucas, and all the posts, and that's it, and all the likes. Right now there are no likes. Cool. And so let's get started. Let's create first of all an AsyncAPI file, or let's create the backend of the server, the WebSocket server. Okay, so let's start with npx create gli app, and we're gonna call it server, just to make it easier. This is going to create a gli is one of our frameworks that works with AsyncAPI very well. It's really well integrated with the specification and uses the specification as a config file. So that's it. I don't want to wait a lot for npm to install all the dependencies. Continue on another terminal, just so you can see. We also have to build our notifications service. So notifications service, yes, spelled. Cool. So I'm gonna do these two things in parallel in the meantime. So this one is installing it's creating the server app and installing gli and all the dependencies, and this one is doing the same for the notifications service. Remember, this is the WebSocket server, this is the notifications service, and they both are going to have an AsyncAPI definition. Yeah, let me check how server is doing. It's gonna take some time. Cool, so next steps are going to be like, once we have our server and our notifications service already created, I mean the basic project, I'm gonna edit the AsyncAPI file that it generates as a demo, let's say. You can see that we have an AsyncAPI file here. We have a bunch of folders and files. We're gonna get into this soon, but we have an AsyncAPI YAML file here. So I'm gonna just demo this, how we can be, sorry, I have to switch to server folder, AsyncAPI, start Studio. Let's use Studio is one of our latest tools to edit AsyncAPI file. It's an editor that works in the browser. Let me check, why is it not working? Okay. Not now. Okay, and it's telling us to convert to the newest version of AsyncAPI. So the latest one is 2.2.0. So I'm gonna convert it, and cool, it's converted. So what is it? So this Studio is our latest editor, as I was saying before, and here we can add AsyncAPI file, and let's just change this. So this is the social network server. This is our server version, doesn't matter here right now, and we're gonna be listening on URL, WebSockets, blah blah blah. We cannot listen on 3000 because we have the front-end server on 3000. So let's just use 3001, and we have another server which is the Mosquito, the MQTT server, and so I'm going to use this test mosquito.org protocol. And oh, my computer is going really slow and having some problems. I'm gonna give it a second. Ooh, it's having some high load. Recording the screen is not for the browser, I guess. I'm gonna close it here. So the cool thing that I was about to say is that while I was editing on the browser, this was editing our file here. It was connected through the CLI, right? When I run AsyncAPI Start Studio, it was precisely connecting the browser and our file system, so I can edit this file anywhere I prefer. So let's continue here. This will be working fine outside this demo, like I'm recording the screen. So yeah, my computer is about to start flying. I don't know if you can hear it, but yeah, it's making a lot of noise. So yeah, I was saying that Mosquito is our MQTT server. I'm using test Mosquito, and MQTT has a peculiarity, let's say, and it's required to use the client ID of MQTT. So to connect to Mosquito, we need to provide the client ID. So what I'm gonna do here is I'm gonna use AsyncAPI bindings feature, which allow us to provide MQTT specific details. And client ID, and I'm going to use social network server, whatever, that's fine. Okay, so we now have our servers. Let's have a look at channels. So this is the demo, and we're not interested in this. We're gonna start by the root channel. So since WebSockets don't support multiple channels by default unless you're using socket.io or something like that, my only chance here is that we use the /channel, or we use something like whatever path we prefer. But that means that we will have to be connecting that path whenever we connect. So we're not gonna do this. We're gonna just use / and that's it. And we're gonna, so this is our server. Our server will allow others, the client, the browser, to publish a message to the server. So we're gonna call this operation on or on like this. Okay. And here I'm gonna use the message like or this, and I'm gonna get rid of this for now, and I'll come back soon. And now I'm gonna use or this like, and our like of or dislike object message is going to be an object, a JSON object. And yeah, so the properties are going to be type, and I'm gonna explain what is it right now. So type is going to be a string, and description of this string is the type. Since we cannot have multiple channels, we're gonna simulate them over the same wire or over the same channel. So we need to know if this message is going to be a like or a dislike or a dislike, something like that. So it can only possibly have two values, either or dislike. I know it's not strictly correct in English, the term dislike in this context. This will be something like undo like or something like that, or stop liking if you prefer. But let's leave it like this. I think it's easier. And so we have one property, which is type, and we're gonna have another property, which is the rest of the interesting data. So for instance, we're gonna have properties. This data object is gonna contain something like, for instance, what is the post ID that has been liked. So it's a number, an integer actually, and ID of the liked post, like it, unlike it, and who is the user, the ID of the user who like it or dislike it, the post, right? ID of the user who liked it, the post. Okay, so we got something here right now. That will be something that's working. Let me open the studio again. Yeah, it looks like it's fine. I'm not gonna use this editor for now, just to avoid my computer from flying, and I'm just gonna leave this view, which is the documentation view. Sorry. So as you can see, we instantly started seeing, as we were typing, immediate feedback on this place of on the right side of Studio, and it's the documentation. So we are automatically getting the documentation, like with really little effort, right? Just by writing the AsyncAPI file. And the cool thing is that you get samples and all this stuff. But that's not only for documentation, and that's something that's what we're doing here. I'm creating this AsyncAPI file, and I get the documentation, but I'm gonna get a lot of more things. Like for instance, I'm gonna get the code actually, or a lot of validations in the code. So next thing that I would love to explain here is that what happens when we like or dislike a message, a publication, sorry, a post. If we like a post, the next thing that we want to do on the server is update the count on the database here, and we're gonna reply, not really reply, we're gonna send a message to all the clients subscribed to the WebSocket server, notifying that there has been a change of likes on the likes count some of the posts, right? So all the clients can be notified saying, hey, so there's a update your count, please, on the front end, please update your count so it can be reflected. Of course, that's an example. You should not be doing this on real life, but that's what we're gonna do here. So as I was saying, we're gonna publish a message once we get this or dislike, and this message is going to be I don't know, like count, like updated count, or no, like count updated. Nice. And let me just come here and let me work here better. Like count updated. So the payload of this message is going to be something like, what do we need here? We need the ID of the post that has been updated and the new like count, right? The new total count. So let me just start then. Type object, properties, and I'm gonna just have, not type, sorry, I'm gonna just have, since this is, oh yeah, sorry, this is a WebSocket event, so we need to have a type, which is the same as this one, right? And okay, I'm not doing, and something is not correct here. Okay, now that's it. Cool. So we have a type field, which is a string, and this is going to be an update of count. And we're gonna have the data, type object, and properties here are going to be something like post ID, type integer, and description is going to be, I don't know, the ID of the post, and total count, which is going to be also an integer, and description is total count of likes for a post, something like this. Okay, cool. So we're writing a lot, as you can see. I think it deserves the effort to do this up front, and we're now saying that whenever the browser sends and we want to compute something here, like the number of likes for a specific post, and then communicate all the browser instances connected to the server that the post has been liked, okay? So they can update. Cool, let me check before we continue. I think that's fine. It should have been updated here. Yes, it's updated here. Cool, so we have our documentation here right now that you can publish this or dislike, and you can subscribe to the count updated message with the following information, and here you have an example. Cool, so we have that. Now another thing that we're gonna do here is, once we have a or dislike, we're gonna also post something. We're gonna send a message to a MQTT topic, right? So we're gonna call this topic post/liked. So here we can follow the MQTT notation, and that's fine, which is the same as AsyncAPI in this case, this is cool. And since we're gonna send, that means that someone can subscribe to this message, right? So that we're gonna use subscribe. That is highly confusing, and we're gonna change this in version 3. So stay tuned. And something that we want to do here is we want to do something like this, and this message needs to be, I don't know, notified the post has been liked, something like that. So we need a message, we need a new message. And the new message, I'm gonna create it here, notify the post has been liked, and the payload is going to look like something like, since we have to specify that post has been liked, at the very least thing that we want to know are the post ID. So we need to know the ID of the post that has been liked and who liked this post. I'm not gonna spend time on the descriptions. You can add it now later. That's fine. Cool. So that will work. Awesome. So it validates correctly, and you can see it here. So people can now subscribe to post liked event because our server is going to send it. So that is here. Cool. Awesome. So one thing before I forget, we have servers. We have two servers, WebSockets and Mosquito, and we need to limit who's going to be, which channels exist where. For instance, this last channel doesn't exist on the Mosquito broker, so we want to limit this to WebSockets, and we say that this channel only exists on the WebSocket server, and we're gonna limit this to Mosquito. Okay, that will be, I will say, most of it. Like, I'm not forgetting anything. If not, we'll find out afterwards. And so yeah, this is more or less the description of the server. So what happens here is that, as you remember, we started putting operation IDs like on this and things like this, right? Only this one for now. We have a functions server here. It has an onHello by default because it was coming with the example that was generated. But we're going to rename it to on this to match exactly. It has to match exactly the name that we're giving it here. Okay. So this function is going to be executed every time we receive a message on this specific channel, right? So every time we receive a message on the in the WebSockets channel, the only channel that WebSocket has, we're gonna execute this function. Okay, what is this function going to do? So this function is going to actually do all this stuff. Like, we need to compute the number of likes and or save the likes, let's say, and we need to store it on the database, blah blah blah, all this stuff. Cool. So I'm gonna close this for now since we're not editing the file in Studio anymore, and I'm gonna install a dependency that is called LowDB. Right, this is a small dependency for working with local databases like this JSON file. And one thing that we're gonna do is, well, I'm gonna start importing it already. I think we don't have to wait for npm to finish again. And LowDB. Okay, so here it is. And yes, so let me check how was this. Yeah. Okay. So I have the documentation right here. You cannot see it, but db JSON. Cool. So we create JSON instance here. Sorry, our JSON database here. And what are we going to do now? So next thing is, first thing that we want to do is we want to read whatever is in the database, just so it's updated. And let's just understand what is inside the data. We have the number of likes there. The number of likes are stored here. See, this is what we're doing right now. And so far, it's not a number, so it's an array of objects with user ID and post ID. So we're not gonna store on plain numbers. We're gonna store more information. And we're gonna also open this. Not open, sorry. We're gonna understand what kind of event are we talking about. Is it like or dislike? And another thing that we'll need to know is the ID and user ID. And yeah. Cool. So that is it. I have a few functions prepared here to compute all this stuff. And so let me just also copy this function, this snippet that I have here. So we need to find out if this like already exists in the database before we compute it, and why. So we need this. We need this. If type of event is like and the existing like index in the array is -1, it means that it doesn't exist. We're gonna store the like on the database. If it's not if it's a dislike and it doesn't exist, sorry, it exists already in the database, we remove it from the database. That's what it's doing. And yeah, and we have to save all the time. That's why you're seeing this. Cool. What's the total count of likes? it looks something like this. So likes, we need to filter every like by those who are about this specific post ID, right? Like we need to count all the likes that are from this specific post. And okay, so let's get into the beauty of this. And we need to, something that we need to know is we're gonna broadcast to all the instances, all the WebSocket instances. We're gonna broadcast that. So we need to that the count has been updated, as we were saying before. So something that we want to do now here is we need to say that this is our event, right? Like the name of our event, and the data is the post ID that we were obtaining here, and along with the post ID we're gonna send the total count that we calculated here, and that will be, I'll say, enough for now. So that makes our WebSocket like our WebSocket server to write on the database. Let's see if it works. So we're gonna start this server npm run dev, and there seems to be a problem with, why is it complaining? Sorry, yeah, I need to update to the latest GLI. Yeah, sorry for that. That needs to be updated on the generator, but it's working. That's the cool thing. Yeah, so it's complaining that GLI is not supporting version 2.2.0. Yeah, indeed, it was created before this version was released, but lately, a few days ago, I updated it to so it supports version 2.2. Okay, so I'm gonna install this dependency, and then we continue. All right, let's check if it works now. npm run dev, and okay, cool. So you can see that we started GLI, it's running in development mode, and it's only using the WebSocket server. Now this can be configured afterwards here. Okay, so we're not gonna use the Mosquito server. Actually, yeah, we're not publishing to Mosquito yet on the code. So we didn't do anything here yet to Mosquito. It's on the AsyncAPI file, but we didn't implement it yet. So that's correct. That's fine. Now, if I go to the front end and refresh, if I start the front end, obviously. Okay, cool. Awesome. So we now have the front end, and let me check. Why isn't it connecting to? Okay, cool. So WebSocket client connected to server, and here we are. Cool. I'm gonna like something just in case, just to see if it works. I'm not gonna like my own post. I'm gonna like the Lucas one, and there is a jump on the front end. I don't know why, but you can see it bumped the number, so that's cool. And let's see what happened. So we received a message from the backend saying likes count updated, post ID 11, total count 1. That is super cool. So it worked. Let me check on Lucas' side. Did it work? Yeah, it did work. Let's also do like here. You can see it here. Cool, perfect. Did it work here? Yes, so it's here. So we have it. It's working. We have a WebSocket server that is storing our information. Now we're missing the last part. We have to communicate to the MQTT broker, and so it can communicate to the notification service and send to Slack. Let's go quickly to that part. I have something here prepared so we don't spend more time. Okay, and I'm gonna explain it now. Let me go straight to here. Okay, so something that we said is whenever we receive a message, a like or a dislike, we gotta also update not only the front end, but we gotta communicate that this event happened. We're gonna do this only on the likes. We're not interested in the dislikes for now. Okay, so only in case this is a like event, we're gonna send a message to post liked channel, which is the post liked
topic in MQTT with a payload of post ID and user ID, and it has to go to the Mosquito server specifically, not to all the servers, just to Mosquito 1. Okay, something that I will. So that part should be done, right? Like we're sending the message. That is done. That is done, but it's not yet completely, because as you can see on the terminal, it doesn't say that it's connecting to Mosquito, and it's because we're not telling this to use Mosquito as well. So I'm gonna update the .m file, and don't know if it caught the update. If not, I'm gonna restart it again. And yeah, cool. So server is WebSocket is running and it's connected to Mosquito. Perfect. So now it can send the message. Let's see if it's doing what it's saying. I'm gonna like another, I don't know, whatever, this one. Cool. So what happened? From WebSockets, we received this event, which is it was sent to Mosquito, and it was broadcasted to WebSocket. Cool, perfect. That's all we need. Now, before we continue, let's go to notifications service and see if it's receiving the event or not. One thing that we need to do here before we continue is we need to create the AsyncAPI file for the service. So, notifications service. Okay, something that we need to get from here is the Mosquito. So this one is only connecting to Mosquito, nothing about WebSocket. And this is going to be notifications service, a different client ID. I hope this is not too long for MQTT. Let's just make it sorted just in case. And yeah, and what else? Yeah, so we need to subscribe to the post liked. And since we're subscribing, it means that someone can publish to us, to this application. And on post liked is going to be the name of the operation. And for the message, we're not gonna duplicate with what we have already. We're gonna just leverage what we have on the server. You can do this, or you can rely on other sort of registries or GitHub repos for your messages, or for all your specific stuff, all your specific AsyncAPI stuff and definitions. For now, we're gonna just do this. Let me just check that this file is valid. I think it's like this. I hope so. Yeah. Cool, so this file is valid, successfully validated. Awesome. Cool. So we now have this. We have the AsyncAPI file, but we don't have the implementation yet. So whenever we receive a post liked, as we said here, we need to what? We need to send a message to Slack, but always. Not really, not always. So something that we want to do here is let's just get rid of this. We're not going to send any message, just receive. And I'm going to just copy what we have on the other function here to access the database. In real microservices environment, you shouldn't be sharing this database, but this is a demo, so don't trust me so much. And yeah, let's just read the database, and we need to know that you are liking other person post, right? Otherwise, this shouldn't be doing the notification if you like your own post. So I'm gonna just get all the users and posts from the database. I'm gonna get from the event payload that we're receiving on the MQTT broker, the post ID and the user ID, the user who liked the post. And I'm gonna get who's the owner of this post, right? So I'm gonna check from the list of users who's the post owner and who was the user who liked the post. Okay, so if with all this information, all we gotta do right now is we need to check if the post owner ID is exactly the same one as user who liked ID, right? In this case, we're not gonna send any notification. We're gonna say it's great that you like yourself, but I'm not going to send a notification. Of course not. But if you're liking other people's post, okay, so sending message to Slack. Cool. Awesome. So now we need to make a call. For making the call, I'm gonna just install node fetch as a dependency, and in the meantime I'm gonna just copy and paste the snippet that I have here. Okay, so we need to access process env Slack URL, and we're gonna make a post call to this Slack URL so we can send this kind of information that someone liked your post. Okay, and that is pretty much what we need to do. The only thing missing right now is exactly the Slack URL that's not in the .env file, and we're gonna add it here. Oh, this is not WebSocket, this is Mosquito and URL. Cool, awesome. I'm gonna delete this URL afterwards, so don't try to use it. And npm run dev on the notifications service and see if it works. Module not found. What? LoadDB. Yeah, we didn't install LoadDB here. Yeah, something that we're missing here is importing fetch. But since I don't have any help on the code editor, it is not helping me, saying that this is not being imported. Okay, so fetch is there already. We're gonna call Slack URL. Awesome. Now, if I just let me just clear the database, all the likes. I'm gonna remove all the likes. Okay, and that should be before I continue. Yes. Oh, we don't have the WebSocket server running. We're gonna start it. Cool. Connected. Frontend is in place. Notification service is in place. So I hope that works now. Let me just refresh. Awesome. We don't have any likes. And I'm gonna like my own post. And let me check. Yeah. So you see notification service is saying that it's great that you like yourself, but I'm not going to send a notification. Awesome. It's working. And I'm gonna a Lucas blog post. So eventually it will get it to notification service, sending message to Slack. Awesome. Let's check Slack. Awesome. We got a message here. Hey Lucas, Fran Méndez liked your post. So that was the demo, my friends. Awesome. So I really hope that you liked this demo. It's a pity that we don't have more time, but I would love to get into more details. Like really, we have lots of things to tell you, and so little time. Just something that we'll love to reinforce in this talk is like we recently this year we joined the Linux Foundation, and so now the project is in a neutral ground, right? And we are growing super fast lately, thanks to Linux Foundation and all the contributors that we have and the users that we have, right? Also, we'd love to clarify that even though this initiative started as a event-driven architectures initiative, and we're still there, right? We want AsyncAPI in the next 5 years or so to become the #1 specification for defining and developing APIs, any kind of APIs. So that means that in the future, you should be able to define REST APIs, GraphQL APIs, gRPC APIs, and event-driven architectures, all with AsyncAPI. Don't get me wrong, we're not trying to reinvent the wheel here. it's by leveraging existing specifications. So you should be able to combine your OpenAPI file inside AsyncAPI and your GraphQL, AsyncAPI being referenced from your AsyncAPI file, and so on and so on. And that means that you should be able to work with AsyncAPI tooling and with the AsyncAPI document referencing other specs, and with a single process you should be able to do all your API stuff, right? And just as a shout out for all these companies using AsyncAPI in production, there are a bunch of them. Really, AsyncAPI is getting well tested and being used heavily in production. So give it a try. And last but not least, we're a welcoming initiative and community. So join us, join our Slack workspace or our GitHub. And even though you might not have much experience with APIs or with event-driven architectures, we're a welcoming initiative, and we welcome everyone to join us. So thanks a lot for watching, and I hope to see you soon. Bye.
Oh wow. Where's Alejandra? Alejandra, where are you? We lost you. Oh wow. Oh, it tells me that your connectivity is very low. We're about to lose Alejandra. Oh, damn. Well, folks, I really hope you enjoyed this really quick demo. Hey, so we got Alejandra back. Are you? We can't hear you. I don't know if it's because you are moving.
Can you hear me now?
Yeah, much better.
The internet died.
My sound is really bad. It's Jonas is saying, really? Why is it? But is it now, or it's been like this for a while?
It's been like this.
Oh,
maybe
I
refresh.
Now I think now it's much better. Sounds better now. When I plugged my AirPods, it connected the mic on the AirPods. That's really bad. Okay, so now it will be good again. Thanks, Jonas, for the heads up. So, anyone has any questions so far? Happy to answer right now. Alejandra, you want to share something with us? Okay, that is completely valid.
You know, how do you always display such inspiration when you give talks? That's what everyone is wondering. They've all been wanting to ask, I think. I'm pretty sure.
I don't think I do. Am I doing this? Well, thanks for that, for these words. In this, especially in this talk, I have to admit that it's a lot of concepts and a lot of stuff, and the rhythm of the talk of the demo is really fast. I even had to cut some words in the recording because it went to 50 minutes. So yeah, only the demo, not the talk before and after the demo. So
only the demo. Okay, I need to help you figure that out after this.
I
can give you some ideas.
I was trying to demonstrate that it is possible to create something like that in about, let's say, 20-25 minutes. I'm hearing myself, by the way. But then I realized that, yeah, you can do it, but not if you're explaining while you're doing it, right?
So it is true, you can create something like I did if you have knowledge about AsyncAPI, previous knowledge about AsyncAPI, in about, let's say, 30 minutes at most. But yeah, problem is in that you have to be explaining and stopping and explaining a lot of stuff, so it's slower. So sorry for this long demo, super long demo. I hope you get the value at least, and yeah, give it a try, because it's really cool. And thanks for your words, Alejandra, by the way.
Oh, you're welcome.
So.
Oh, wait. Oh, sorry.
No, go ahead.
I'm supposed to make this better, not worse. Sorry for joining, everyone.
Okay, you want to share something before we finish this stream?
Oh, sure. I just want to say I'm so excited that I'm able to be here with you all on the very first AsyncAPI 2021 conference. I'm really excited that we had people from my own country, Mexico. So obviously I was like, oh yeah, that's awesome. Mis paisanos, gracias por venir. Thank you for coming. And I think it's really cool how we have people from all over the world that speak different languages, not just Spanish and English, but there's people from that were speaking French, I think, also. I saw from some of the marketing that was going out. And we have people from all kinds of different cultures too, which is really interesting. So I'm excited. It's really exciting to have to get to see so many people from the community and to learn from everyone, I think.
Yeah, I agree. I actually, this is what makes me the most happy, right, about this, that we get people from all over the world. This year we didn't have so much participation from Australia. I guess it's because of the schedule, right? Like the time zone is not really helpful. But yeah, that so Lucas is saying that. So Martinka is Lucas' wife. So so Canela is there.
Hola, can you see the dog at least, even if you can't see my face? Canela, tienes tu audiencia aquí. Aquí tienes tu audiencia. Canela, aquí mira. Dile hola, Martinka. Hola, Martinka. Well, she got too excited. She's
lovely.
Canela.
Oh.
Yes, I think she knows that she's getting attention, and she's always happy with that.
Yeah, Maciek is right. It's not
daughter, not wife. Sorry.
Her wife. It's his daughter. Yeah. I always get confused with names. Cool, folks. So with Canela and Alejandra and Martika and Lucas and myself and all of you there, we have to say goodbye until tomorrow. Remember that tomorrow we're starting again at 12 p.m. UTC, and it will be last day conference this year, and also AsyncAPI anniversary. So yeah, let's celebrate. Bye. Cheers.
Bye.